in transformation. You can unmute your mic to speak, or you can either chat in the chat box. I want to know how your journey has been on the course DIS in Transformation College. I want to hear your opinion, just one or two persons before we proceed. I see Amaka is here. Good morning, Amaka. Bolariwa, good morning. Mr. Michael, good morning. Good morning, Mr.
Good
Tobi.
morning, sir.
So should I call names of
Good
who?
morning.
All right. Let me start with Amaka. Good morning. Are you there? Okay. So tell us what your experience has been so far in this course, Diploma in Information Systems. I want to know what your experience has been so far.
Good morning, sir. Can you hear me? Good
Yes,
morning,
I
sir.
can hear you loud and clear.
Okay, my experience has been educative, most especially the practical class for SQL. It's really been educative. The last class was really stressful anyway, I won't lie, because of the time we learned. And I've not been able to go back to it and sit down and go through it. But so far, the whole class has been really educative, informative, and what I'm realizing that if I put the work to it, I know I'll go far. So thank you so much.
All right. That's amazing. That's amazing. Okay, I can see Mr. John Sunday. Good morning. I'm new here from Lagos. Welcome to be here. You're going to find it very interesting and very informative here, and I'm sure you're going to enjoy the journey. So before we move forward, I would like to ask one or two questions regarding database. Give me a second while I pull this up. Sorry, I'm having a little bit of difficulty here. Just give me a minute while I sort it out. Let's hold that on for a minute. So most likely okay, welcome Mr. Steven. Welcome to the class.
Thank you, sir. Thank you, sir. Good morning, everybody. Good to see you.
Good morning. Good morning, Mr. Steven.
Thank you, sir. How was your night, sir?
I'm grateful, very grateful.
Yeah, good to see you.
So basically, before we dive into today's class, and the topic for today is system analysis, designs and development. But before we go there, I want us to tell me what you've learned about database on your own. Like after the classes, have you been able to do any research personally to improve your knowledge on database so as to help you get the best understanding? Because once you've gone to the class, you've attended the class, you've taken notes, personal research or personal research is always helps to in what you have gotten from a lecture. So I would like to know, anyone here does personal research after their classes? Nobody. It's not like all names. You can as well just send a message in the chat box. All right. I can see nobody's ready to respond. Okay, moving on. Before I introduce the trainer for today, our assessments will be coming up soon, and the timetable and what have not will be sent to the group. And without further ado, I would like to introduce our trainer for today, Mr. Tobi Omokore.
Good morning, everyone.
Good morning, sir.
I'm happy to be here. I'm happy to share my knowledge and my experience with everyone. You know, it's a very good thing to get the opportunity to impact what you know. So thank you for having me.
You're welcome. So he's going to be taking us in systems analysis, design, and development. So I want us to put our minds together and focus, because this sometimes can be technical and at the same time it can be straightforward. But I want us to put our minds to it and get this particular topic. All right, so you can proceed. Thank you very much.
Okay, no problem. Let me share my screen so that. Can everybody see my screen?
Yes.
Okay, so good morning once again, everyone. My name is Tobi Omokore. I'm an IT consultant and a business developer consultant. I'm conversant with programming language, cloud computing, database, and IT support solutions. I've worked in for startups as CTO, for also for established business as IT manager. So I'm a little bit vast in the topics because most of the aspects described in or I'm going to be talking about, they are different, but they are also together in the sense that it takes different experiences and different situations to get to encounter some of these topics. Not everybody will get to work with everything all at once. So everybody has most of the time everybody's prolific in one or two of these things. So let me get right into it. The topic for today is system analysis and design for application development. This actually talks about the systemic process of building information systems. Information systems are very delicate because they serve as what we call is a product. Let me just say is a product because you are more or less, when you look at the way OPay, all these apps, how they treat their apps, they treat it like a product. And for a product to work well, it must serve the need that is required. Like you must define, okay, why am I building this? Okay, once you outline that, okay, this is why I'm building it, to solve a particular problem. Sometimes, some people build these things without doing what you call feedback, which you are going to see most of all these things as we go along. And these feedbacks help to shaping what you're actually building and make sure that it serves the basic needs that you want it to serve. There are other advantages into system analysis and a good design. That's efficiency, scalability, and user friendly, because there are certain rules that you must follow when you are building these things. For example, it must be efficient. Efficiency means you want to transfer money, you log in, you don't want to do too much. You just want to transfer your money and get it over with. No long story, nothing. It must be scalable, which means if 1 million people should come tomorrow and say, we like this thing, we want to come on it. If they come on it, will it crash or will it stay up? Then user friendly, where the button is supposed to be. It should be there. It should not be hidden somewhere, because this user friendly comes in two ways. You have the UI UX and you have the interface. The UI UX, which is the experience, while the UI is the graphical representation, while UX is the experience of that graphics. For example, login screen now. We all know email is always before password. The moment you put password before email, most people will not even answer you. That is one of the unspoken rules that are actually in design and analysis, because you must first do your analysis, check other systems, look at what they are doing. Then you'll be like, okay, if I want to improve, do I want to improve this, or I just want to go with them? But you must always obey certain rules for your application to be friendly, acceptable, and be efficient. Please don't you can ask questions. So coming, I want to hide this. Okay, so system, sorry, I want to hide this. Okay, what is system design? So system analysis and design. So system analysis is the process, like I said, of studying existing systems and business processes to understand requirements, identify problems, and determine how technology can provide solution. That is what I'm saying. I was saying initially, if you build something that nobody is going to use, or it doesn't meet any business, even if they use it and it doesn't meet any business needs, it's going to stay very long on the shelf, because even you that you are building, you are going to be spending a lot of resources to keep it afloat. So you don't want a situation where you've created something and there is no way to sell it, or there is no profitability in selling it. For example, we all know ChatGPT. ChatGPT, as free as it looks, a lot of people don't know that the free version is actually a fraction of what you can use it for. In that kind of strategy, they call it premium, where you have free to a point. Then if you want to proceed, then you now have to pay. Then you have system design. System design, that's the module, interface, and data for system to satisfy specified requirements. For example, some systems require database relation. There are two types of database: relational and non-relational. So there are some systems that require relational. There are some that don't require relational database. For example, I'll give you another example when it comes to modules and interfaces. And for example, architecture, you can choose. I will classify this into two. I will say you have the hybrid and you have the cloud and you have the on-premise. Let me use that first, because when you have to now go further, you now say, okay, what does it require? What are the components I will need for cloud? What are the components I will need for on-premise? On-premise, which means that the server, everything is in your building, is not managed by any other person. It's in your building and you manage it. So it means that 24 hours there must be power supply to your server. Then you talk of modules. The module still depends on what you are choosing. Interfaces. Interface as is just the, like I said, UI UX. And it's very very important, because you must follow, like I said, the rules. And like I said, data relational, non-relational, and you must make sure that what you are using will make your application do what you want it to do and meets the business needs of why you are creating it. Then application creation, the creation of software applications that solve business problems, meet user needs through systematic planning and implementation. This now has a lot to do with what you call the process of building. When you are building, there are certain rules, like I said, you must follow, and there are ways you must always get feedbacks. There are different ways to get feedbacks. For example, you can talk to the stakeholders, that's the CEO, the board of directors, then they will tell you this is what we want. This is exactly how we want it, and sometimes it might be the users. If you notice, sometimes when you go on Instagram, one interface or something has changed, or some probably they got certain feedbacks that this will look better here, why this will look better here, let's remove this here. For example, you see iPhone, they went to their new UI, which is the glass. If you are using 13, I think upwards, I think 12 upwards, you see that they've changed their OS to give everybody a fresh perspective of their product. So, the issue was people were always complaining that there's no improvement, there's no improvement. So they went to the visual side of things by improving the visual and still leaving the function. So it created a little bit of fresh air, but they still need a lot of planning and implementation, because these things are the things that are going to guide you for a proper result. The feedback, the stakeholders input, sometimes it's questionnaire. Then after that, then you go into the like I said, feedback. That's where the stakeholders are talking with the programmers. Okay, where have you guys been? There's a process or there's a procedure you use. It's called agile, and agile is one of the procedures, but agile is the most accepted, let me put it that way, worldwide, for these things, because it creates a kind of a feedback loop where everything is working according to, you can track everyone, because when you are building things like this, it's always a team. So it tracks everybody through the way it is being set up. There's what you call sprint. Sprint is when you have meetings every 4 days. Then what is wrong? These are your tasks. Why have you not finished? These are the blockers. Okay, what do you need to complete it? So there is always a constant, because there's always deadline for these things. So for you to meet the deadline, you must always follow this planning so that your implementation can show results. So like I said, this is the life cycle planning. When you define the scope for this planning, I would have loved to show you a document. There's a documentation that you must first drop. That documentation is what would say, okay, what are we building? Why are we building it? When should we finish building it? What we need to finish building it or to build it. I'll give you an example. For companies like OPay and the money companies, the fintechs, they require several things before they can even think they want to come to light. And those things, you have to go to data protection, you have to collect license from data protection office, you have to go to CBN, you have to go to money laundry, anti-money laundry, which is EFCC. So you have to collect some criteria before you can even think of, okay, I want to. So those things have to be in place. Then you talk of analysis. This analysis now is majorly on the front end, back end, and the programmers. They have to say, okay, this is what this person wants to build. What do I need? Like for bank apps now, you know that once you leave, bank apps will log you off normally. It is when you come back, then you have to input your password. It will be a very, very bad design if you have a bank app that will be left on, even though you leave and come back maybe in an hour's time, you will still be logged in. That is a very, very bad design. That's why you have things like understanding users' needs. You must understand that, okay, in this sector, what are the things that I must not do? And what are the things that I must do? OPay has a very, very nice cache system where if you've sent money to someone before, the person's account number is stored in their in-app. and it makes it easy. Those things they've analyzed, people analyzed our normal bank transfer processes, and they've seen that, oh, if we go through this route, I think we can get people to use our app more because we will be cutting down on the process, to get this thing done. So they were solution oriented in their analysis, and they thought of how to, you know, meet business needs. Then when you talk of design, architecture, like I said, the user interface is very important. You cannot put password before username. You cannot put login above everything. You have to follow this architecture that is accepted. Database structure, like I said before, how do you want to set up your database? The primary key, I heard him talking about database, so I guess that we are all familiar with database structure. So you have the primary key in your primary table. Then you have to know that, okay, what do I want to be common? That's the primary key and secondary key in each table, so that everything will be relational and you can pull data from everywhere. For example, if you are creating a social media app now, where your profile is stored is different from where the comment is stored, because the comment must have a key relating to the post, so that they will know that this comment was made under this post. So the comment will not appear under another post. Likewise, your profile, there is a key that is conversant with you, that is appointed to you, that once you log in, that key is what you'll be carrying everywhere. Once you go to your profile, it goes to the profile database and it matches your key and it says that this is the person. Then it brings your profile picture, brings your amount of followers, bring your post. So that is how it works with database structure. Then technical specifications. In this one, I will discuss on API. APIs are what you use to interact with different systems. Is application interface, an application interface, but it works as a key too. But because they give you the key, then there's a way it works in your application. You use the key in your application, then you can pull data from that source. For example, now in Lagos, all your bank apps now needs an API key. Each of them will have to give their API key. I've forgotten the name of the central bank platform, but everybody's API key is there. So when you type in somebody's account number, the API key goes there to search for, okay, you said this bank is GT. Okay, let me go to GT's database. The account number, let me bring it out. So those are the technical specifications, the kind of API you need to pull data from where, and what kind of data do you want to pull. So all those things are things that are part of your design, because you cannot have a A's profile picture where the account belongs to B, So there are some certain things you must put into place. Now, for implementation, code test and deploy system according to design specification and requirement. You see, this implementation is very, very technical, because I'm sure you must have heard in the news where they will say Microsoft, their whole server crashed or something happened. It might not be that they were hacked. It might be that there is an update they just implemented that they didn't test properly. They just deployed and it crashed the whole system. Maybe two things were conflicting, and that would be the end. The whole system will come down. I know a lot of people are conversant with iPhone. When they update their OS, my phone is getting hot. This after the update. All these things are because the testing they did was not adequate. So it created problem in life. And that is not for us in the IT industry, that is actually a normal Tuesday, because you can test your code properly in the testing environment. It works fine. Everything is working perfect. Once you upload it to the live server, problem will start and you'll be wondering what happened. and the whole system can crash from there. So this implementation is very, very important. The best way to mitigate this is to replicate exactly what you have in your life as your test, so that you know that as it's moving properly and there won't be any issue. Then for maintenance and support, update enhancement, this one has a lot. This maintenance and implementation has actually crumbled a lot of businesses, and that is because the people or the team that you assembled to build this thing, maybe you now became very arrogant to them, or you didn't treat them properly. And one of them, maybe the person that even built the backbone, says, "Well, I'm tired of this, I'm leaving." And you not knowing his job or the effectiveness of his job, you say, "Go, get out, blah blah." And the day a problem will come, they will now tell you that that person that left is the person that is maintaining this thing. And so you need to maintenance is very, very important. In maintenance, most of the time, companies give what you call equity to their best staff when it comes to the system development. The core person gets percentage, so that if anything should happen, his money or his shares is inside the business. He can't go anywhere. If he should go anywhere, he will come back, because if the business should fail, his equity too has also failed. But a lot of people always want to pay them off. It is never the best practice, because you are going to pay a lot of money. Because whenever there is an issue, he's going to collect another money. And that is how he will be collecting money, and he is not tied to your company. You need somebody that will be tied to your company, that will be like, okay, the success of this company is also my success. Steve Jobs had the other guy, Steve Wolowitz, he was actually the programmer and the system design person. Steve Jobs was the marketer. He knew how to sell anything. So that was the dynamics they had. The guy later left. Even Spotify too had a guy that was part of their team. He's the one that built Spotify is the first streaming platform. He's one that built everything from the scratch up, and they had to give him equity because he needed to be there. So the maintenance, updates, and sense of the system is a very, very key factor, because your system is not the only one that meets the business needs in the real world. So you need to be able to adjust to changes. You need to be able to adjust to feedbacks. And without this maintenance person, the maintenance people are mostly the people that will actually do the implementation too, because they understand the system. They are with the system. So it is maintenance and implementation are very, very key, very, very important. No matter the planning, the analysis, and the design, the last two, if you don't get people that are extremely skilled to do these last two, is workflow and pain points. Engage stakeholders through the process to ensure solution meets your business requirements. Sorry, can you guys hear me?
Yes, sir. Yes, I can hear you clearly.
Okay. So when you are doing system analysis, you can, for example, now there's what you call in business, there's what you call stoop low to conquer. And when you stoop low to conquer is when this number two, observe current work process. You go into where it is done, or you get somebody or something that does what you want to do, then you study it. And you be like, what is one problem that I can solve that this particular system is not solving? That is where you now come to user interviews. So the users, you ask them, you have to go and look for them. You ask them, sorry, this thing that you are using, how do you use it? How is it like? What is that one thing you wish it does for you or is doing for you? Or you want it to do for you? They will now be like, okay, it doesn't do this. Because even Bill Gates said it that your angry customers are your best customers. Because if another person can solve the problem they are complaining about, they are out. No user is faithful. Only family and friends are faithful when it comes to business. Once you want customer, you must provide what they want. You must provide the solution that they want, especially after they've complained to you. Once they've complained to you and you be like, okay, this complaint, how is it? What's the business angle to it? What's the possibility? How many people will complain about this thing? You have to look into it because is that small thing can make a lot of people leave your app. That small thing. It's just like what OPay did and other banks. It was very easy. OPay just made sure they had the highest uptime and very quick transfer. Very simple things. But those two things, people were not like, no, OPay, it's good. Even Money Point is getting to that point too. So they are building efficiency, by understanding user needs, and understanding how everything works. So user stories and use cases too is very important. What is it used for? How can I improve it, like I said, so that I can have an edge when people are using it? Then you talk of systemic investigation. So they say apply structured methodologies to analyze existing systems. Like I said, identify inefficiencies and determine improvement opportunity. Like I said, process mapping and documentation, data flow analysis, performance measurement. Exactly what I said. Performance, they just made sure their app was up and you can transfer easily. As simple as those two things were, they were the things they used to take the whole market. They didn't do any bonanza, they didn't do any giveaway. They just created efficiency and speed and simplicity. And those three things just made it above every other person. And their security too, top notch. So those are the principles of system analysis. So gathering techniques, like I said, interviews, one-on-one conversation with stakeholders, that's the owners of the business. Because at the end of the day, they are the ones that know why they started this. And they are the ones that will tell you, from my years of experience in this. So all those things now, the things you are going to put down in a code form and say, okay, these things you said, this is the code representation and this is how it works in the software, Then observation, direct observation of user performing their tasks, how people use it. Is it that when somebody wants to, let's say, I'm trying to use something we all use every day. If you notice, when you want to transfer money through OPay and you copy the account number, maybe from WhatsApp, when you get to OPay will tell you, should I paste? All these things are not just things they just decided to put there. These things are things that they got from observing, different people and observing different systems, and they saw that, oh, okay, this is how every other person is doing it. We can make our own processes easier because they've observed different things. They've observed the inefficiencies and they've observed the requirements that is needed and how we want things to be done, and they followed it through and they executed and it is turning out great for them. Then you have structured data collection tools to gather survey and questionnaires. You see, survey and questionnaire, yes, you use it to get the pain points from the users. For example, you want to create a football app or a football social media app, or let me use football. You cannot go to doctors, you cannot go to lawyers, you will go to football fans. You can even go to football watching centers. get questions. How are you? What are you doing? How good do you like watching football? How was your club? What is the problem you always face when you're watching football? If you're online, what do you need there? What is the problem online? you know so all these things now are the things you will ask. So that those things you get from those guys, you will now put it inside the app as the solution for them. So you already know their problem, even though you know their problem, but now you personalized it, and turned it into a business, and now you can sell it and you can make money from it. And that's another thing you must always look for. How do I make money from this, apart from you even giving the solution? Because I've been to certain accelerators, been part of certain accelerators and incubators. One of them is Founders Institute. And Founders Institute does not joke around. They just ask you, how many people does this solution serve? If it's less than 2 million, you can't do business. You have to look for a solution, another solution that will serve up to 2 million people upwards. If you cannot serve up to 2 million people upwards, you don't have a solution. You just have something you want to do for yourself. And that is how it works. They are very strict with their matrix. You have matrix you must use. You go out, talk to people. And another question they will ask you is, how are you going to make money from this on the get-go? Immediately it comes out, what is the money making strategy? That is all. So when you have these things, you will understand that creating softwares and creating systems is not something you are just supposed to do. It's something you are supposed to go through a process, planning, and that is what they are revealing here today. Then workshops, collaborative sessions, bringing together multiple stakeholders to discuss requirements, resolve conflicts, and build consensus on system features. Now, you all know this one now, we use our beloved China and America. You know, if you notice the way they've been doing things, at the end of the day, two of them will come and talk because it's business. They will come and talk. And we are discussing something here. Them, their own, what is at stake is a lot higher, hundreds of billions. So they must talk. They must come together. This is not working for you. This thing is working for you. Let's look for how we can make it work for each other. It is very, very important. So yeah, so that is it. Sorry. So types of system requirements, functional requirements. Define what the system should do. Like I said, specific behavior, features, and capabilities that the system must provide to meet business needs, which is user authentication and authorization. That was when the example I gave about bank app, when you are logging in. Once the person logs in, once the person swipes off, the session should close. The person should log in again. Data processing and calculation. Hey, you don't want to transfer 20,000 and see that 100,000 has left your account. You don't want that. So the data processing and the calculation must be correct, because if it is not correct, you cannot use it. The system is pointless. Then report generation and export. We all know, who did I send money to yesterday? Who did I send money to on the 5th? You can easily go back. You and I will never use a banking app that you cannot go back to check who you transfer. There's no log. They call it log. And you must be able to export them in PDF or Excel so that you can share. Maybe you need proof of account or proof of address. You can easily, for example, some banks, I don't know if they've started doing it, but recent times banks don't allow you download your logs. That's your transfer history. While OPay, all these new generation ones, sharp, you just see it. They will send it to your mail and you have what you need. So integration with external systems. If you want to transfer from OPay to GT Bank, you must be able to do it because that is a core function. Not everybody will be transferring to OPay to OPay. They will want to cross GT, UBA, and all that. And once you cannot do that, you've lost a chunk of customers or you've lost a chunk of users because if I cannot transfer to every other bank, I will just use the one that I can use to transfer to every other bank. It's as easy as that. So all these things are things you have to put into consideration. So now, non-functional requirements. These ones now, the non-functional requirements, they might look like um they are not practical, but they are very, very practical. So they are should perform quality attributes and constraints that affect the overall user experience and system operations. These ones now are not, they are more or less things you cannot see, but they are very, very important and they are very, very systemic. You know, performance and response time. Thank God I've been using an example that has constantly been in line with what we're talking about. Performance and response time. I said it, that was the only thing OP had, it got, you know, security and data protection. Everybody has this, but there is a level to it. There's even requirements from the government that you must protect people's data. In as much as that is, a lot of companies still breach this, but it is a must that you must have, you know, the license, data protection license, saying that I will comply to this. Then scalability and reliability. If I open the app in the midnight, will it open? Will it do what I want to do? That's reliability. Scalability. Once it becomes very popular and a lot of people start using it, will it be able to scale the amount of users? For example, yesterday or so, stroke this morning, NYSC site went down, you know, and this is time for registration, which means this scalability and reliability is out because the essence of scalability is that a lot of people will come at once to use it, and you must be able to have a server that will not crash when they come. So you already know the requirements because you know that this is the time they will come. So you are supposed to have placed things. We are still going to discuss this when we go to cloud computing, you know, this true. Then reliability, now the system is down because you cannot scale. People will not be, they are not reliable, but it's a system everybody has to use. Usability and accessibility, it's the same thing. If people cannot use it, it's a bad design. If it's not accessible, it's a bad design. If you cannot scale, you remain small for a very long time and you won't be able to handle big task or big user base. And once you cannot handle big user base, usability is downhill, accessibility is downhill. But this accessibility now depends on, okay, I want to use it. How do I access it? There are certain systems that takes several processes and very high technical support, you know, to access. For example, I will say QuickBook. If a lot of people are conversant with QuickBook, you can't just install QuickBook and start using. It's not possible. You need several technical um, help before you can use it. So let's move to the next slide. System design fundamentals, system architecture. This has to do with wireframe and okay, no, yeah, and yeah, we'll go to interface. System architecture defines the overall structure, components, and their relationship. Appropriate architecture patterns like client server, microservices, or layered architecture. All these now are, they are very if you are conversant with cloud computing, that's the AWS and the likes. This system architecture is very important because there's what you call decoupling. You still get it. That's when you bring small systems together to form a big system. And you do it in such a way that if one small system should fail, it is not going to affect the failure of the whole thing. So that's what you call decoupling, where one thing does not affect the other. And there are several ways to decouple. Is as if decoupling can be as easy as your office, your system. Maybe there's a UPS there, and there's an extension, and you plug about 20 things on a small UPS. Decoupling can be as easy as removing every other thing and just putting your CPU. So that if light goes off, your CPU will be on, because that's the most important thing. So everything has gone off, but your CPU is still on. So there is a level of backup that you've done by decoupling. So that's then when you talk of microservices, there's what you call SQL. SQL means is a queue service where if you, let's say, you send in 100,000 requests at once, that SQL will not process the 100,000. It will divide it according to what the server can carry. So all these things now are system architecture designs. It will not put everything into the server once. No, it will divide it. It is 100 per second or 200 per every 5 seconds. So it will create like a queue for you. That's a service too, and it's a microservice. It's a small service. You won't know it's there, but it's doing its job. Then you have layered architecture. The layered architecture, you talk of all this now. You can't talk of on-premise, because that one is just a server in your office that other people will connect to. But when it comes to cloud, there are so many things that you need to do. Layered architecture now, you can have something like they call it CloudFront. CloudFront is more or less like a caching system, where let's say you've gone to facebook.com before. Now, if you go to facebook.com for the first time, the CloudFront will go back and search the server and bring it to you. Then it will now store your IP and then cache that page. So when you come back, it will appear as if the page is loading faster. The page is not loading faster. It's just that there is a cached data already. So it shows you that first. Then to now go to the server, then pick small things that has been updated or that has been changed. So that is an architecture that when you implement it, you have a very, very good and robust system. Then you have database design. Like I said, what does your database, what is required? What are the requirements? For example, let's say you have a database of everybody's bank account and their balance. Then peradventure, you now made data type for balance to be alphabetical, and everybody knows balance is numeric. That is a problem. The system will always throw in an error, because you are telling the system that this table, everything inside, or this column is letters. Then the system is seeing numbers. The system is going to fail. The database will throw in an error, and you will not be able to retrieve data from it. Then security. Not everybody should be able to access your data, because data is money. Once they can access your data, username, password, you are most likely going to be in trouble. There was a scandal that happened in America because of this data security, where there was a man, he created a dating site, something like that. Then an hacker hacked their database and took everybody's data. Then from the data now, the hacker now realized that even married people are in the dating site. Even himself, the owner, is married and he is on the dating site, and he has done things with several women because of the database he has. And they had stolen the database, so they know everything. And they blackmailed him to drop money or else they will release it. He couldn't drop it, and they released everything, and a lot of marriages scattered because of database insecurity. There was a time too we had the same issue in think campus, but Nigeria, we don't say those things so that they won't create panic. So, and these guys did something and they had to pay ransom and did. I remember a long time ago. So data security is very important. There's what you call ransomware too. The same thing with the beating guys. That's what they do. Ransomware, they steal it, they ask you for money, or they infect the system in such a way that you can't access it again. Then they ask you for money. So yeah, that's why security is very, very important. And your database too, the schema must be very, very good. The data flow, your data warehouse, yeah, and if you have a good data design, there is what you call business intelligence. And if you have a good database design, you can perform business intelligence on a daily basis in the sense that you can create a data flow and create a dashboard through Power BI. That's for business intelligence. Is very close to database and data analysis, and you can be seeing your sales every day. You can be seeing your sales year on year, day on day, the difference between yesterday's sales and total of yesterday's sales, today's sales, every day. All you just need to come, click, you open it. Oh, this is what I made yesterday. This is what I made it for yesterday. What was the difference? What did they buy most? And that is how big companies actually make decisions. That's why you see December, there are certain types of adverts, certain types of ginger. So that one now, over the years, they've discovered that during that period, a lot of things that have to do with happiness, celebration, sales. So those are the things that are going to be pushed. All these things are based on observation, like I said, business intelligence. So interface design, like I was saying, interface design, you must always follow the user workflow that is accepted in that field or in that sector or in most of the apps that perform what your app or your software or your solution wants to perform. You must always have the guideline of what to do. The APIs for system integration and data exchange. What this means is that when data is coming in, how do you receive it and how do you display it? It's also important to interface design because data can come in now and it has four things. It's coming with four things: your name, your let's say your name, your profile picture, your amount of followers, and your amount of following. If the programmer or if you don't put in place that okay, this placeholder will hold username, this placeholder will hold profile picture, this one will hold follower, this one will hold following. It only display the things that you've programmed for it to display, no matter the data coming in. So you must always make sure that the system is built in such a way that all data coming in are accommodated and accounted for and will display. Very, very important. So popular development methodologies. This is what I was saying. Waterfall technology, sequential approach to which this must be completed before the next task begins. Well, you see this waterfall, some people use it, but it is not fast. It is not fast because the reason why, and it is not advisable. And I'll use Nigeria as an example. You give a programmer something to do for you, and you tell him that I need it to be done in a month. So within that 1 month, you didn't bother yourself. You went to do other things, or yeah, you went to do other things. Then you now come back and you're like, after the 1 month, hello, where is it? Then it tells you NEPA was taking lights, the roof came down, something happened, this happened. You wasted the whole month, whether you like. There's nothing you can. You've wasted the whole month. You've wasted. There's no story behind it because that 1 month you cannot get it back, and he has wasted it for you. That is why the waterfall methodology, even as a Nigerian, I don't even advise it in our ecosystem because we have a lot of things that are constraining a lot of people. So you cannot use it because you must always know the blockers. We call them blockers. What is blocking this job from being done so that you can treat it immediately. That is why this waterfall, I won't advise people to use it because it will waste your time. But when you talk of agile, agile is in agile now, there is what you call collective intelligence. When you talk of collective intelligence, you talk of everybody's input, flexibility, collaboration, delivery, you know, and you must always meet. See, they said short development sprints, like 3 days, 2 days. Hello, where are we? What have you done? Okay, what do you need? Continuous user feedback. This is what I've done. Yeah, you check it. Ah, this are still not working well. Okay, this task is incomplete. The next sprint, how far? This task, this. Are you going to work on it? Okay. So next, so there is constant every 2 days, 3 days, 2 days, 3 days. There is constant. Then adapting to changing requirements because there is constant. How are you? How is it going? What do you need? You can easily adapt to like, ah, okay, this API that we are looking for. How much is to get it? $10, $20. Okay, let me pay it tomorrow. Then we continue. What else do you need? Ah, this cannot work. This cannot work. Okay, let's work on this. But you see, this 1 month on this waterfall, you might not know what's happening until after 1 month. But agile, you will know immediately that there's a problem because of the way agile works. Agile follows through and it is a constant something and is very, very important. It creates very, very fast results. Very, very fast results. And it like I said, collective intelligence. So it is a collaboration, something, a team collaboration. As the product designer is designing, the front end is picking it from there. He's going to do his own. As designing this page. So there is a lot of movements happening, a lot of activities happening, a lot of feedbacks, a lot of changes that will be happening. That's why it's called agile. So let's move on. Okay, agile development in details. Sprint planning, define goals, laser to estimate effort for the upcoming sprint iterations. That's why I said feedback. What is happening? What are we going to do now? 2 days after the second day, what have you done? What have you not done? What is required? Let's change it. Retrospect. What did we discuss yesterday? What's the improvement? What do we need to improve on? Then development, code testing, integrate features. Like I said, there's what you call QA. Once you've implemented something, QA pick it. QA after 2 days, QA will give you feedback. This one is happening, this one is not good though. Then the programmer will go back. Okay, this. In 2 days' time, we are back at it again. Okay, you've implemented it, the QA goes back. Okay, it's now working fine. But I noticed this. They fix it. So it's a continuous, then sprint review, demonstrate completed features to stakeholders and gather feedback for improvement. This sprint review now, it might look like is going to happen in 2 weeks. This sprint review might happen also a month later. But what you would have achieved, you cannot compare it to the waterfall because you have iterated, you have done things, you guys were constantly on it. So when you are presenting it, you can defend what you are presenting to stakeholders. So if they want to change anything, they'll be like, oh, okay, this doesn't look good here. We want this to be here. This doesn't look good here. We want, and notwithstanding, sometimes the only thing the stakeholders know is the business process. When it comes to the design and the way it will work, most of the time is the programmers or the UI UX or the other team because there are two teams here, the business team and the system team. But everybody will have to work together to complete the system. So sometimes the stakeholders might ask for feedback or might ask for improvement that is going to disturb a lot of things because sometimes they will just say something. I want the house to float. You in your own head, you are already thinking of, hey, you want the house to float. That means I will have to dig the ground. That means I will have to do this. That means he does not, the stakeholders don't know those ones. They don't know how that works. So sometimes when they talk, you too, you have to be like, this for it to work this way, we need, because a little change can create a whole lot of problems. That's why it's a system. A lot of things depend on each other to work. So that to put in mind that sometimes the stakeholders might not understand the technical process it takes to get things done, which you have to explain. If not, agile will fail. Because if we are going to be iterating every 2 days, and you know that this thing is going to take you 1 month to even do because of the requirements, you cannot have agile for it. So that is where another problem is. You must always tell the stakeholders that this is what it involves, this is what it entails. Is it possible or is it not possible? Thank you. System modeling techniques, use case diagram. These are showing how users interact with the system, identifying actors, use cases, and the relationship to understand system functionalities. Now, this visual representation now shows, you know, some softwares now or some app, they used to show demo. Click here, click here to tell you how certain things work. Say, okay, when you click here, there are some apps I know that have all those animated demos. Now, those demos are actually very important, to show that, okay, because nobody will call you to ask you, how do I transfer money? You must always assume that they don't know. Don't ever assume they know. Don't ever assume they know. Because once you assume and they don't know, that is the problem. That would be a problem for you. So, data flow. Several representation of data movement through a system, process, data store. This one now talks about, let's say you want to transfer money and there is no success message. It will be very confusing. It will be very, very confusing. There's no success. You just click send and nothing happens. You don't know that, okay, the money has left my own side or have gone and it has showed success. Without, as simple as that success tick is, we all know it can make you very, very uncomfortable because you don't know the state of the action you just performed. And once it goes, it will reflect straight in your history. That is showing that the data has been stored and it has gone. So that will keep your mind at rest, because all these things they might look small, but they are things you cannot ignore, because they are user centric. Let me put it that way. Then entity relationship diagram, database design, models showing entity attribute and relationship, token structure. Like I said, this one now, this entity relationship, I'll use social media software as an example. For example, now you want to see the list of your friends on on Facebook. How does the system know that this person is your friend? It is the relationship schema that the database have structured. That is how they know. So once the person clicks friends, under the friend column, it will add your what is it called, your ID there. Okay, this person has become this person's friend. And once he has the ID, when you now go to the friends tab, you've already instructed that, okay, once they click friend, just show the picture of the person. So the system is going to fetch the picture or the profile picture of all the people in that friends column and will display them and their name, and it will display them. If that relationship is not there, there's no way, no matter how the person click friend, even though you people are in the same house, no matter what you do, it will not show. If there is no relationship, if there's no schema relationship, if there's no key relationship, between the two tables, because profile table cannot be the same as friend table, will not be the same as your timeline table. They will be very different because the data needed to show in each of these pages are different. They are similar, little similarities, but they are different. The only thing that will be conversant in all the pages is the user key, user ID, which is what will identify whoever is on. They don't use name, it's that user ID they use, and it is unique for every person. But name can be the same for 100 people, but user ID can never be the same for everybody. So that is why they have, Mr. John, thank you. That is why they have all those schemas where everything connects with each other. Okay, user interface. Sorry. Okay, user interface, user-centered design. Design interface based on user needs, behavior, and mental model. Conduct usability testing and iterate based on user feedback. Now, like I said, user feedback. You go on the app, or you get, normally what people do is, once an app is being built or has been built, you get people you call QA. QA are the ones that will test your app. You give them documentation of what the app is supposed to do. So when they see it and they use the app, they will compare. Okay, this thing this person said does this. Does he really do it? Okay. And you don't give one person, and you don't give a friend. You give a professional, because that feedback is business. Feedback is business. So they will tell you, okay, according to what you said, this, and the QA must also understand customer mentality, must understand how the customer of that sector or that solution think, so that they will be able to help you adjust your software. That's the first set of people. The second set of people is, like I said, the football app. Go to one watching station or football station, sit down beside somebody. The app has been built now, something small. Sir, I would like for you to test, or go to all those football groups. I would like to test an app. I want you to be, you and 10 people to be the first testers. You guys will sign NDA, because it's very important to sign on disclosure. You will test it for us, and you will be the first set of users, and probably little monetary token. You will test it for us, and you tell us what you think, what you don't like about it, what you like about it, and what we should improve. It will be a 1 month process. So they will use it, and they will tell you, oh, this is what I think, this is good, this is not good. This, we love it. We think it's the best thing to ever come out. Very good. But you must also get, or try and get, what is wrong, because everything cannot be perfect. No software is perfect. They must always tell you, okay, this one is, I think this thing, there's something, you know. Somebody will give you, even if the person is just doing bad belle, the person will say something, and that thing will help you. Even if the person is bad belle, the person just feels, with this one be creating. So what do you think of it? So once the person tells you, you're like, oh, okay, okay. Then you go back and you check how many people talked about that problem. Because somebody that has already seen what they like might not focus on what they don't like. Once what they like is very exciting to them, they might not bother on other things. And what this person likes, the other person might not even care about it. The other person just wants to know if can be bothered about another function. And be like, this other function is not working well. I don't like it. And you cannot now say, because somebody is happy with one function, you have to also work on something that the other person is saying. And there are several, there's what you call blue ocean and red ocean. That's a business. It has a lot to do with these things I'm saying. Then simplicity and clarity. Create clean, uncluttered interfaces. Like I said before, the normal spaces that are supposed to be there should be there. Like I said, guide user through, like that's what I was talking about. The demo, use clear labels, login should be login, not log. The intuitive navigation. Where is in all apps, where is home? Home is always the first icon in your navigation. You cannot put it in the last, you cannot put it in the middle. It is the last, it is the first. Then post, new post is in the middle. There's a reason why all these things are rules, but you as a user, you can't know until you are ready to build something. Then they will not be telling you these rules, or you will be seeing these rules by yourself, because when you now build, the people now be like, why is this one here? Don't you see Instagram? Don't you see it is here? The moment they start doing that, because there's no how, people will always compare, no matter the software, they will always compare. Can't you see this one is always here? This one is here. Why are you putting your own here? Because they are used to Instagram. Now you are giving them an habit change. It's going to be very difficult, because yours does not look like what they are used to. So they might not be very comfortable, because their brain will now have to start processing something else, because the interface is somewhere else. I am a very, very big example of that. Like, I did IT support. I'm already conversant with where icons are on my own system. When someone calls me, I have a problem, if I go to their system, the first thing I do is I try to look for where things are on my system. That, okay, where is Chrome? Where do I put Chrome on my system? Naturally, that's where I'm going. But I now realize that, this is another person's system. If I now look, I don't see it. Sorry, where is your Chrome? Do you have Chrome? So that is how it works too. You must make sure that you build according to what is accepted in that sector or business. Then consistency, maintain consistent design patterns, technologies, interaction through the application. Like I said, to reduce learning curve, people, they are not ready to learn, user confusion. Nobody has time. The attention span is now actually 3%. So if you cannot get somebody to, sorry, if you cannot get someone's attention in 3%, you most likely will not get their attention at all. Okay, for that period. They are gone to another thing. That's how low it is. So you must always you must make sure that your users don't get confused, because once that happens, they are most likely going to have problems. Then accessibility, design for users with diverse abilities following. Sometimes they consider color blindness too when creating apps, especially for older people. When you are building something for old people, for example, it is not rocket science. Your font must be very big and very bold. And it must be very, 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 very extremely simple. But your font must be big and bold, because they don't have time for tiny, tiny text. They can't even see it. So all these little things, I'm just giving you a peculiar situation. It might not always be the situation, but I'm just giving you a peculiar situation. If you are building something for old people and you know that this app is old people that are going to have it on their phone, you must always make sure that the text is big and it's thick, bold, so that they can easily see what they are looking for. And all the buttons, anything they want to look for, should be in that front page. Should not be, they can't even go anywhere else, or else they will call somebody. So you must also understand how each user works, so that you can satisfy everybody and give them what they need. Yes, database design in system development. So, like I said, identify entities. That is what and what you want to be there. Attributes is the name, text. Like I said, the name is they call it character. If it's number, you put it there. It will be num, numeric. If it's There are some that are both numeric, and most of the time usernames are both numeric and alphabetical. That's what we call alphanumeric. All these things must be there. They must be defined from the beginning. In the practical class, you will see something very similar. So focus on business rules and data requirements. Like I said, make sure it follows. It's just like you now. I'll use bank application as an example again. You have a bank app, it doesn't show your balance. What is it doing? There are so many things you must put in place. Like I said, the data flow is very, very important. Logical design. Transform conceptual design into logical structure with tables, keys, and relationships. What I've been saying since. Apply normalization rules to eliminate redundancy. This redundancy means repeating a record, and once you repeat a record, what it means is that, let's say you sent a post, and once you send the post, the data will be written somewhere. You must make sure that the data is written in one place, and there's a systemic way of accessing it in all other tables. You cannot put that post now, you cannot store it in profile, store it in this, store it in that, store it everywhere. Then they will now have what you call duplication. That is going to create a problem for your database. Then physical design, implement the logical design specific database management system, considering performance, storage, and indexing strategy. Now, performance and indexing, they are very similar. And the reason why they are very similar is that if your index strategy is very good, the speed at which the data is retrieved from the database will be very, very fast, and that will help your performance. So index and performance are very, very, very alike. Storage, where once the storage is not yet full, it's not yet full. But you see, performance and index, if you don't index properly, the retrieval of data from the database is going to affect your performance. Because another example, you want to check your profile, the indexing of the application is not good enough. You have to wait. No matter if you have 5G, then you have to wait, because there is what you call system operation. You send the data to the server will do its own thing too. If the server side, the architecture is not correct or is cumbersome, it's going to lag. And once it lags, it automatically affects performance. Storage will still be fine, but performance will be affected. So those two go hand in hand. Yes, testing and quality assurance. This is the QA I'm talking about. Now, unit testing. Test individual components and modules to ensure functions correctly in isolation. Verify that each unit meets its design specification. Now, this now is QA that is going to do this, because like I said, you give them the documentation, they hold this software or the system where you say this one works this way. You check, is it working the way the person is saying is working? Then integration testing. Test the interaction between integrated components. Components to components, identify interface defects and ensure user proper data flow between modules. Now, what this means is talking about API. If you retrieve data from another, let's say, another system through API, you must make sure that like I said, all the data flow properly and they are represented through maybe a text field or a picture frame or something. Make sure that all the data that is required to be retrieved are retrieved, and they are properly retrieved and properly displayed. Yeah. So all this now can be tested from, we call it JSON, before it now goes into the main interface. Then system testing. Test the complete integrated system to verify it means. Now, unit testing, integration testing, when you add both of them together, you have the system testing. This is where the components becomes a system. They are no more testing each function. They are not testing the overall function, the overall integration. That's where you now have the system testing, because the system testing comprises of the two of them. Because unit testing is more or less like front end, that's user experience. Integration testing is more or less like back end. You can't really see most of all these things normally. It's through the JSON you now see that, oh, these are the information that the system is retrieving. Are they correct? Are they complete? Are they in the right format? And all that. Then the system testing tests the integrated system to verify it meets the specified requirements and perform correctly in the intended environment. Does it do what it's supposed to do? Does it log in how it's supposed to log in? Now test the whole system from the beginning of the flow to the end of the flow, from settings to profile to everything you want. This is where you have the system test. Then user acceptance testing validates the end user to ensure. This is where I said you go and meet, like I said, football software, you meet 10 people. Can you help us check this thing out? Help us 2 weeks, 1 week, just be using it. Tell us what you think. Tell us what you need to improve. Tell us this. If they now say, oh, this is very good, you now probably most of the time you give them questionnaires so that you can streamline the information you want. So give them questionnaire. What do you think of this? And give them questionnaire in such a way that any opinion can be quantified. Let's say, for example, how good is the app? 1 to 5. So if it's 2, pick 2. So you can now go and do your average. But there will still be space where the person will write his opinion, But in most cases, it should be 1 to 5, 1 to 5, but there will still be text boxes. But that 1 to 5 now will give you a collective insight. Because if everybody should write different things, for this question, for all the questions, it's going to be very hard to correlate everything. But if you do 1 to 5, if first question you are doing for 10 people, 4 picks, 10 of them picks 4, very good. There's no need for any other thing. You all know everybody thinks it's very good. So that is the way. But if it's opinion based, some people might write things that will even get you lost. So that's why it's very good to specify and to direct the way you want your feedbacks to come, so that you can use it to implement whatever it is you want to implement. Implementation strategy. Replace the old system entirely with the new system on a specific date. You see, this direct cutover, it is not advisable. Like, it is already there. High risk if problems occur. If it is a system that there are a lot of people and a lot of other systems depend on. Like there was a time Microsoft had an issue with an update and their server and all the hotels, all the airports, I think in UK also, could not, they could not fly. Like the planes could not take off because their systems run on Windows server, Microsoft server. So there was nothing. All flights were grounded. Because you cannot fly without these systems, the radars and all those things. And that thing was caused by an update error. An update error. Places like Russia did not feel it or did not have that problem because Russia doesn't use Windows system. Then parallel implementation. Run both old and new systems simultaneously for a period, lower risk but higher cost. And yes, like I said, this is when I said have the same environment in test and in life. Though realistically, you can only reduce it. You cannot totally predict what will happen when you go to life. That is the truth. Nobody can predict 100% that this is what will happen 100%. A lot of times you will think you built it up. You that update is very up to date. You will take it to life to just tell you error, and you will now start wondering that what's happening, And once you duplicate the two of them like that, then you can now start implementing things on the test. So once you start implementing, since you know it's the same system, once it works here, you implement the one here too. Okay, it's working. So you are watching them side by side. Then phase implementation. Phase it. This is when you do it in stages, gradual process. This most of the time for phase implementation, you don't always notice because there are a lot of times that Instagram, all our apps have actually updated and we don't notice. Is most likely due to this phased implementation because direct cutover might require you to install the app all over again because they are changing a whole system. But you see this phase, you'll just be dropping it small, 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 small. You don't have to install because this cutover might require some other things that the old one does not require. So you have to install again. But you see first they'll just be dropping it small, small. You won't even notice that there's an update. The only time you notice is when they bring out a user agreement. I don't know if you've noticed that you just open maybe Twitter, you just see we have a new user agreement, click to accept. They've changed something that they are telling you to agree to. But you will not know. You can't really know because sometimes changes are not physical, they are not interface, they are systemic, So you might not know. And like I said, longer period because as they are doing it small, small, you too, you'll be seeing it small, small. Okay, this has changed. It's one thing. It's easy for you to see one change and you're like, oh, it's one. So, but if it's a whole system, is quite a lot. So, phased implementation is for me the best strategy that I can use for updates and deployments. Yeah, project management is system development. Now, you have planning, scheduling, and team management. Now, project management is very, very important because that is the person that puts everybody in check. A project manager can also use agile, or let me say they use agile, but most of them are not agile certified, but you can use agile. Now, create detailed project plans with timeline, resources. Like I said, they are the ones in charge that, okay, this project we want it to end. They are the ones the stakeholders even talk to the most because they are the ones that interface, they are the middlemen between the programmers and the stakeholders. So they are the ones that translate what the stakeholders are saying to the programmers. And they are the ones that will be on the neck of the programmers to get the job done. Work like part of their plan, part of their job for planning and scheduling, work breakdown structure, resource planning, risk assessment, timeline development. Now, there are certain systems too that you use to monitor all these things to keep track. For example, I think Stack is one of them. Yes, Zoho is one of them. There is a Nigerian company called Invex. Yes, they do that too. Project management, where you have everybody working for you. They are there. Their task is written. As is written there, they will see it that, oh, the manager has given me a task, implement so so so. Once he has finished implementing them, he will just go done. The manager will see that, oh, this person has finished this one. If there's a remark, you can just write your remark. This particular one, oh, this. I will need something from the front end guy. So now the project manager will be like, okay, new task for the front end. Back end said he needs this from you. Timeline, this. You tag the two of them, front end and back end. So two of them will see that there's a new task. You know. Now, team management coordinates cross-functional, like I said, analysts, developers, testers, stakeholders. They are the ones that bring everybody together. Role definition, communication, how, because it is very important that when you are doing this, you don't break communication. If the project manager has been the one talking to you as a front end person and the back end to do so so so, let's say you now have a back end that has a very bad character, we now fly over the project manager, we now go and meet the stakeholder to be talking directly to them. The stakeholder will not understand what you're saying because he's not a technical person. He's the project manager that can talk to the two of you because he's the one that understands both languages. So you can go and meet him now. The SQL we are using, the .NET, the stakeholder is just business. It doesn't. Maybe his business is even, let's say, e-hauling. That's likes of Uber. All he knows is how to, as a business person, he knows the partners that he will go and meet to get this thing done. He doesn't know SQL. That's not his function. Then you go and meet him. You go and meet him and he starts telling you, you start saying the lyrics. I don't understand what these ones are saying. So you have to now still go back to the project manager that, okay, that's the person that understands what you are saying by SQL. Then you now tell that the stakeholder in the language, they understand. It is very, very important that in this process you don't break communication and you don't jump communication. Very, very important because it can cost you your job and it can cost you integrity. Because, like I said, the system is, you must obey the rules of the system. If not, you will not get the actual result you are looking for. Yeah, risk management in system development, technical risk, technology failure, integration challenges, performance issue, and scalability concerns that can impact the system functionality. Now, technology failures. Now, let me, for example, you have on-prem. Okay, let me give an example of when I was working in an hospital in DI as the IT manager. There was a fire, and the server, they use what you call an EMR, electronic medical records, and the server is inside the hospital, and there was a fire. As the fire started, it was an electric fire, so they needed to put off the power supply. So once they did that, the server is down. The server becomes down. There's no two ways about it. There's nothing anybody can do about it. Once it goes off, it goes off. If you try to access it, it's not possible. That's the technology failure part. That's why a lot of people would prefer cloud. No matter what happens, your data, everything is still there. If that server should burn, all your data has burned. Nothing can be done. So on-premise is cheap, but these are the risks. Integration challenges. Can they work together? For example, there are some times that you will notice that there are some softwares that are not compatible. For example, let me use Android phones. For Android now, there are some times that you want to install an app, they will tell you the phone is too old. The OS on the phone is too old for the software you want to install. Or like iPhone, they will tell you from iPhone 6, iPhone 7, WhatsApp is not accepted any longer. They will create the integration challenge for you. It's not as if WhatsApp cannot enter that phone, but that integration challenge, they will create it so that you will not be able to use. So when you try to install it, there will be an error, you know, and that is one thing that you should always look out for. Okay, this is that, and that's what always happens too when you want to move from test environment to live. Maybe something that you've used does not correlate with a dependency in the live server. Maybe that one is old version. You need to update it, and you didn't know that on the test everything is updated. On the live, that particular one thing is not updated. You now transfer it, then there's an error. You now have to start looking. Though with the log, you should be able to get what's wrong. But those are the integration challenges that we normally um, face. Performance issue, like I said, once you cannot index your database very well, and once you cannot provision a server that is strong enough to carry what you are doing, and you don't have enough caching technology or a very good caching technology, you are going to have performance issues. Because imagine comparing, let's compare two softwares now. One has caching, one doesn't. The one that has caching, immediately you open it, it shows you something. Even if that thing is not the latest thing it's supposed to show you, but it shows you something. The other one is still loading. You are still waiting. This one is already showing you something. So when you use psychology, you now see that the ones that have seen something in their mind, the app is already working. Meanwhile, it has not updated. It has not brought in new information. It is showing you something that is stored the last time you were on it. And because it is the last thing you saw, you'll be very comfortable with it. Meanwhile, this one is still loading, and before to now show you new information, this one already showed you something. So that is another and that one too now has a lot to do with the performance issue. Then you have scalability. Like I said, if 1,000 people should come at once, will it crash or will it continue working? These are important questions. And if it is on-prem, if this happens, you have scalability issue, all you need to do is just increase your RAM and increase your room. Then you are more or less like you scaled, which is the same thing you would do for cloud. What you just do is you just provision extra server or you provision a bigger server. That is all. And there are ways when we get to cloud, this scalability, there are more things to discuss. Then project risk, schedule delay, budget overrun, resource constraint, scope creep that could affect project success. Now, schedule delays. That's why I said the deadline that we put, are we on it? Budget overrun. You told, let's say, the backend now wants to pay for server provision. Then it tells you the price is 2 million for it. Then you give him the 2 million. It comes again and it tells you, that has changed though. It's now 5 million. Oh. There's already a problem. If you knew it was 5 million from the beginning, it's a different case. But if they come and start doing that, you start having doubts. Because once information is now turning 2, 3, consistency will be a problem. That is why before you document anything, there is supposed to be thorough research, and this, like we said, the system analysis, so that you will know the requirements for all these things. If there is a budget overrun, you will have resource constraint, and it will affect the project. Then you have business risks, changing requirements, market conditions, organizational changes and user changes, user adoption challenges. I'll use different um, apps to talk about different risks. Changing requirements. Remember, for example, there might be some things now in, let's say, I'll use OPay, that OPay will tell them, the government or CBN will say, this particular thing, we don't want it again. It has been banned. They will all have to remove it. Or they tell all of them, you must do KYC by adding NIN and BVN together, not one. You know, if they don't adhere to it, they will most likely be fined. Market condition. Remember Gokada, Maxi, those guys came with bikes. And the government came one day and said, sorry, we don't want your bikes to be on the road again. The market condition has changed. And there's nothing anybody can do about it. It's not anybody. You cannot, you've built, you've understood the market, everything, but it has changed. Now, if you notice, the only person that survived, or the only company that survived that, was actually this OPay still, because they now had to pivot straight into something else. And that's the banking. They just focused on the banking. They could not do the back again. Organizational changes. Maybe the CEO there before, let me use Apple, was Steve Jobs, and he was an innovative person. Remember, there was a time that Steve Jobs brought a marketer from Pepsi, and they voted him out as the CEO of the company. And the Pepsi man could not do the numbers or the designs Steve Jobs was doing. He even went to open another business, Pixel, and he made a lot of money and sold it. They now had to call him back, and he fired everybody. So the organizational changes created a work culture that wasn't fit for what they were doing, and it was a business risk that lost them a lot of money. Then user changes. See what is happening in Nigeria, for example, now. Everything is difficult. The economy there's inflation. There are some things that 5 years ago you easily spend money on that now, sorry, that now you cannot spend money on it like that again. You will think twice. Is it necessary? Is it important? Moreover, it's now more expensive than before. Then user adoption challenges. This one now has a lot to do with knowledge gap and technology gap. For example, when you look at China has gotten to the point that where they pay for things with their face, with their palm. If you do that in Nigeria now, and if you even go to market alone, this show market, or you go to a local market, they cannot use it. They cannot use it. There's no even two things
Sorry,
about
sir.
it. They cannot.
Are you still on risk management?
Yes.
Okay, because someone just said the slide was not moving, and I'm just confirming.
Yeah, I'm on risk management.
All right.
I'm talking about business risk.
I'm just using this to call the attention because we'll be having a 30 minutes break soon. So
Oh, okay. Please just let me know when you want me to stop pause so that we can have the break.
I feel 12 o'clock is fine.
Okay, 12 o'clock is fine. Okay, let me time myself then. So that is the problem with user adoption. Sometimes they might not be able to use what you are bringing. Sometimes it might be too advanced for them to use. So you must understand the people you are, or the users that you are providing this solution for, and how they can adopt it easily. It shouldn't be too complex. Now, project risk. like I said, schedule delays. Okay, we discussed that. Mitigation strategies, proactive planning, contingency measures, regular monitoring, and adaptive management approaches. You know, this adaptive management approach now has a lot to do with you've built something and it does, let's say, I'm looking for a very let's say it does something a certain way and people are like, we don't want it that way, oh. We want it another way. People, you keep getting the same complaint, we want it another way, we want it another way, we want it this particular way. You've gotten two, three, four people saying, why is this thing like this? Why don't we get notification for this? Why don't you have to adjust and adapt to what they are talking about. For regular monitoring, it is very important to monitor the performance and the server that you are running. Like I said, I said something about the database. You can have your business intelligence dashboard, and you can be viewing it every day. If your sales is going low per day, you will see it there. If anything is happening, you will see it there. That what's happening yesterday, day before yesterday, and if you are having sales in a particular product, you will see it there. So those are the things that will make you make very quick decisions, informed quick decisions. For contingency is you have other plans. There's what you call in cloud now. There's what you call what is it called? Triple point of failure, where you have, let's say, you have a server in you have a server, you provision the server in UK, then you provision another one in South Africa. If the one in UK should fail, you configure it in such a way that the one in South Africa will pick up so that you will not have total failure. Then you have another one in another place, you have like that. So if one should fail, the other will pick up. Then you can go and find out why that one failed. Because just because it is online or because it is cloud does not mean it cannot go down. That is the server. At least I think last 2 weeks, AWS server went down and a lot of people could not do things. Yeah. Yes, documentation and communication. Requirements, documentation requirements. Now, I said at the beginning that a document will be first prepared before anything is done. A document must be very comprehensive, that this is what the project entails. The user stories, that means what is the pain point, why are we building this, um what is the flow going to be like, what is the problem, what are we trying to solve, what are the criteria that once this project meets, you will now say yes, we have completed the project. That's the requirement document. Yeah, the design documents now is what you now call wireframe. Now that wireframe now, the wireframe, architecture diagram, database schema, interface. Now the wireframe is the interface design. Now the wireframe is done by what we call the product designer. What will design how the home page, the login, everything will look. So once they are done with that, the front end and the back end, especially the front end, we look at it, then it will build something. The database is the back end. And all these things from design, the design documentation must be gotten from the requirement documentation, because that's the one that will state everything. Then the designer with the the product designer will pick it up, then will create his own. He is going to do his own research, will create his own, then the backend too will pick it up, will create the system architecture and database, while the front end will create the interface, but the technical specification and the system architecture and database will be done by the backend. But the front end is now going to pick for the interface design and development, working closely with the product designer. Then user documentation, user manual, training materials, system to support end user and effective using. Now, for user documentation now, after everything has been built, how will it be used? The documentation of how it will be used must be written from beginning to the end. That is where you have the project manager who liaise with the team that built it. Then they will create this user documentation. This user documentation, remember one time that they were saying something about that they banned Twitter. Then somebody came up with an app called Crow. You now discover that the person got the same policy license with one other app, and they reported that app and they brought it down. They reported the Nigerian app and they brought that app down because they copied the user some things from those guys because they were not authentic, and because the Play Store guys, the people that regulate it, know that it is not realistic for you to have the same. It means that you are leading your users astray. So they will have a problem with it because the two softwares or apps are not the same and they can never be the same. So they actually brought that system, that software down from App Store, and I can remember. So that is why your user manual must be generated by you, and you must know the front and back of your software and the workflow. You must just know everything with your team so that you guys can create this user manual. So that when a user is reading the manual and say, okay, it's just like when you have an electronic tool that you bought, a new one, you will check the manual to check certain things. That manual now, they would have sat down to write, to document every single thing, in the system, how the system operates. They jot every single thing, write procedure for every single thing. Very, very, very important. Then stakeholder communication. This is between the project manager and the owner of the business. Give reports, meetings, feedbacks, so that the stakeholders will know that okay, work is being done, our money is not going to waste, and we are going to meet deadline. Very important. Okay, they are going to meet deadline. Fine. So that is how, because apart from the software being built, there are other things that needs to be done physically that must align. That is when I said I was talking about the anti-laundry, the database protection, documentation. All those things now are done offline. You have to go and do them, and it will most likely be the stakeholders that will do that. So the stakeholders most of the time wants to know the situation of the software, because some of this documentation that will be gotten, there will be a team from the organization that will come and check your system out. So there must be a good communication between the stakeholders, the project manager, and the team building, so that when that time is near, or when it is that time, everybody is in alignment. Not that the stakeholder will get the license, the software is not ready, then they tell them it's ready, they now come, nothing is happening, they can't show anything. It will create a lot of disaster. So communication, especially that documentation, is very, very important, and keeping stakeholders afloat, especially feedback, telling them what is happening. Do not lie, because it's very important. So that helps too in building systems. Okay, imagine trends in system development, cloud native development. Yeah, building applications specifically for cloud environments, leveraging scalability, flexibility, and cost effectiveness. Well, for cloud, it is a very dicey topic, because one thing about cloud is you can start cheap, yes, but as you are going up, as you can see, as dollar is going up, your bill will also be going up. Now, for cloud is good because they do what you call pay as you use. And pay as you use means that something you are not using, even if you've configured it, if you are not using it, you are not going to pay for it. It will be there, but you are not going to be paying for it. Now, for scalability, I said something about scalability. And scalability means that if 100,000 people should come on the app now, it will be able to hold it because of there's a system in the cloud that helps you scale. And what it does is if you have one server running and that server can take 100 people, you can actually configure in such a way that once it's more than that 100, provision another server. You scaled like that. That's what you call scaling. Then once it goes back to maybe 99 or 98, it will shut down the extra server. It will now leave you with one server, which what you started with. That's what brings about the cost effectiveness, because you don't pay for something you don't use. You only pay for what you use. Unlike on-premise, once you buy the server, you keep it and if the light use or no use, it has to be running. And even if it is even way bigger than what you are doing, you don't have a choice. Now, for on-premise, people buy by predicting that, oh, we are going to be big, so they buy big from the beginning. But for cloud, you can start as small as possible, and as the business needs, you can be provisioning more servers. There's low code platform using visual development environment to accelerate application with minimal code. This one, they call them pick and drop. Yes, there's one like that. It's called Bubble. Yes, bubble.io is pick and drop. Then for children, there's I think it's called Scrabble. Or forgotten the name, pardon me. Now what that does is that it helps children code and it's pick and drop. You can write logic, we call it logic. You can write logic with it. It's pick and drop logic. Everything's already there, just pick. So those ones are not, you can't use them for extensive systems. You can't use them for extensive systems because extensive systems, you need to customize a lot of things. Meanwhile, if they are telling you less code, means that less customization. That's what it just means. So you have to be careful in choosing this low code because you might have done a lot of things before you now realize that this particular one thing I want to do is going to be very, very difficult. And sometimes they are not compatible with certain integrations, certain server, certain APIs. So this low code is for children. Let me just put it like that don't need to write so much. Adults can use it, but it cannot perform extensive function. For example, I built using that Scrabble app, I built something for children for multiplication. The guy is running, then a question comes, 1 plus 1, then the answer is 2, continues running, with something like that. Then another obstacle, 2 plus 2, something so simple, that's what the low code platforms are for. But for one full customization, we go for the proper native development, cloud native development. Then you have microservices. This is what I said about decoupling, decomposing applications into small independent services that can be developed and deployed separately. That's what I was talking about. That if one should spoil, it doesn't affect the whole function. Every other thing will be working. That's what you call decoupling. When you decouple everything and you make sure that the whole system is not weighing on one thing. Like one thing should just fail, every other thing will fail. Then you have AI integration. Incorporating artificial intelligence and machine learning capacity to enhance system function and user experience. You see, for AI, AI is very interesting and very vast, and AI can solve a lot of your problems easily. But the problem is skill gap. A lot of people don't know how to do this. This particular integration, there are two ways you can do it. There's one that you can do that you will incorporate AI into your core app. And what that does is that, let's say somebody is using your app now and wants to see record of 2 days ago. You can just go to the search bar. Hello, give me records of my transfer from Tuesday to Wednesday. Enter. The AI will go for you and go and bring it. That one now, the AI is incorporated into your software. Then there's another one that the AI just works as an agent. I think that's one a lot of people are conversant with. When you chat with, maybe you go to, let's say, Jumia.com, then Jumia has an AI bot. Then you be like, hi, the bot will answer you, what do you want? You tell the bot you want so. The bot then goes to the database, because AI agents require database to work, because that database will be like memory, because that's why they are called agents. They are specific to certain profession or task. And the only way they can perform it very well is when you give them what you call you give them files, core files that they'll be using to operate with people. So once you say, okay, I want to get iPhone 17, the AI will go to the back end and say, okay, out of all the documents, did they drop the price of iPhone 17? If yes, it will tell you, this is the price. If no, it will most likely tell you, why don't you contact this number for further, conversation. But it is always good to always update your AI to have all, so that it will not, communication will not be changing hands anyhow. Because some people might talk and they say it doesn't know the Bible, and that's the end. They will not. So you need to mitigate for a lot of things. So AI can solve a lot of problems. You just have to know how to apply them. Then DevOps practices, integrating development and operations for faster, more reliable software delivery and deployment. This DevOps practices is still what we were talking about, the agile, so that things can be fast and you can build something that, because everybody's hands were on deck, nobody was slacking. So you are looking at the documentation and you're comparing it to the result, and you're seeing that, okay, everything is working fine. So these DevOps practices, agile is a very core aspect of it. Let me see. Okay, I will stop at key takeaway for.
Hello, sir. It's time for the break now. So we're going on a 30 minutes break.
Okay.
This is 12:05. We'll be back from the break by 12:35.
All right.
Yes. So we'll be going on break now. Please, you can stay logged on or make sure to come back by 12:35. Thank you, everybody.
Okay. Thank you.
The break is over.
Okay, thank you very much. Let me share my screen so that we
You're
can
welcome.
continue. Host has disabled. I can't share my screen, please. You need to enable it.
Emmanuel, kindly make him call. It's done.
Yes. So let's continue. So for best practices for success. Now, these best practices, sometimes the truth is that a lot of people don't often like to go through the professional way. And what happens is that once you don't do that, your result is going to be affected in terms of execution and the system that you built. Now, for let's look at the best practices for stakeholder engagement. It involves users and stakeholders throughout the development process. Like I said, when we're talking about where to get your information from, you talk of the stakeholders, you talk of the users. That's when you talk of questionnaire, surveys, talking to stakeholders, because the stakeholders will know the business, will know the end product, but the users will determine if it solves their problem or not, because they are the ones that will pay for it. They are the ones that will remove their money from their pocket and be like, okay, this is what my payment, this is what my money, and they will pay for it. It must meet real business needs and it must be beneficial to the users. Extremely important. Be it emotionally, be it financially, maybe you make more money, be it makes them happier, it makes things easier. It must satisfy their needs one way or the other. Then you look at iteration too. Iteration has to do with feedbacks. When it is ready, you see this iteration now, the stakeholders don't really have a say here, because they will just tell you this is what I want the business to do. But how it does it now is this iteration. This iteration now, it gives, you have to build a system where there is continuous feedback. I said something about getting maybe 10 people in that particular sector. That's where I used football. Give them, use this thing for 1 week, then give them a questionnaire. The feedback they give you will determine what you will eventually do and how you will do it. Because there's no point in doing a product that only you love. You must do something the users love. Very, very important. So you don't want a situation where you've used 3 months to do something. That is when the users are now having a feel of it. And they now tell you, 9 out of 10 now tell you, this particular thing, you don't want it, or you should do it like this. That means you now have to go back after you built everything, you know. And sometimes some things depend on some things to work. The apps can be very funny. Some things might, we will still get to that section where we get to hierarchy, inheritance, and all that. Some things need some things to work. So if they don't get those, if they change one thing, you might have to change like 3 things. But because it is a technical change from the back end, a lot of people might just think it's something that just changed this. So you must make sure throughout the development life cycle, you have feedbacks that you are using to make sure that everything meets the business need. Quality focus. Prioritize quality at every stage through comprehensive testing, code reviews, and review and adherence to development standards. You see, um, this quality when it comes to testing is what I've been saying. Then code review is very important because normally the best practice is code review and development standards. They are somehow alike because code review is if A should write the code and B should read the code, can person B understand what person A has written? And in case, let's say, I'm looking for a section or a class out of my code where the post button is, when you have a source code of about 1,000 lines of code, it will be very hard to know where the person is, where you find what. So there is always what you call comments for coding. So those comments now are okay. Let's say, okay, you see code for posts. So you know that, oh, this means that from here to here, it means that this is the code that is responsible for posting. So if you want to change anything, you look at it from there. Then that's where you now have inheritance, where you can reuse code. So we are still going to get there. So all those things are standard so that your code base won't be cumbersome and you won't have to be repeating codes. So that's what adherence and code reviews is talking about. Testing, we've already talked about that. you give people, stakeholders, and QA, quality assurance guys to test for you that okay, and the documentation, okay, this is doing what you are saying that it is supposed to do. This is not doing what you said that it is supposed to do, something like that. So those are the best practices that if you follow them, you would actually build a sustainable product. Key takeaways: systemic approach, follow instructed methodologies to ensure comprehensive analysis and design that meet business needs. This is very, very important because you see, this systemic approach now, most of all these things are not, they are very practical, but they are not things that you can just write and you just leave them written. They are practical because they are things you have to do. Because after you analyze, you have to implement. You cannot analyze without implementing. And most of your implementation will be based on your analysis. So if your analysis is flawed, your implementation will be flawed from the beginning. So it is very important that your analysis, what you want to achieve, there is a clear statement to it that this is what I want. And once you have that clear statement, then you cannot translate that into a technical statement where all your programmers will now come together and be like, okay, this is what you want. Okay. Then you must make sure, like we're saying, needs the business needs. Very important because you can't build what only you will love. You must build what everybody will love and will make money for you or make life easier for people and in return make money for you. Then user-centered focus, very important. Your users are your customers. There's nothing you can do about that. Your users are the ones that will pay for your app. And generally, users have what I call shakara. They have because they have choice, multiple choice. And that's where competition comes in. And for competition, problem with most software people or most companies that they focus on competition. They don't focus on the users. In the sense that what is A doing? Let me quickly copy it. What is you don't know A's long-term plan. So you cannot just they will not tell you because everybody has their own trade secrets. So you have to focus on the people you are serving and how you can serve them. But a lot of companies actually focus on competitors. So they always do things to go ahead of competitors. No, competitors will not make you money. It is the users that will make you money. So it is the users you have to focus on, get their feedback, get their pain points, and get what they need so that you can serve them because that is the end goal of the whole endeavor. Quality and testing. You must always test. Very important. You must always test. You must always, for example, let me give you an example. If you look at most of our phone companies, you look at Apple. Apple does not do one thing. Apple's headquarters, you have a lot of things they do. Same with Samsung. In fact, Samsung's headquarters is like a university. They have the sound part, they have the medical, they test a lot of things and they do a lot of things and they make sure everything comes together as a system. So testing is very important and maintaining the quality of what you are doing is very important because the quality will translate to performance and performance will translate to user satisfaction. So there are steps to it. You can't expect user to be happy with your product. You must make them happy with your product. They will not be happy if you don't provide what you're supposed to provide, no matter what you say. So if you're advertising a bad product, nothing happens. You are just advertising. So you must always make sure your quality and testing is top notch. Anytime the person wants to use your app, make sure you have a system that makes sure that your system is up 24 hours because you never can tell when somebody wants to use your system to make a very huge transfer. And nowadays, as we all know, internet has no control. Somebody can come online and be like, I tried to use this app today and that's just the end. You just see 5,000 people leave your app just because one person said something and 5,000 people can relate, you are in problem. And another thing, another person can come, this software is so good. I use it, and you can get another 5,000 people to register for your app just because one person said something good. So you must always make sure that your own part of the job is done and done perfectly. Then continuous improvement. As we all know, this was not what Facebook looked like when it started. This is not what Instagram looks like when it started. They continued iterating. And one secret that they use is they change their interface so much. And that's because they want the app to continue to look new in your face. They make subtle changes. So it makes it look fresh and new in your faces. Exactly what Apple did with the glass interface for their new iOS 26. You they know that okay, people are getting hold of the old visual. Let's do something new. So they created a transparent, glassy feel on their phone, which they used to improve their system because there must be continuous improvement. Even after the system is ready, you need to continue, iterating. Very important. So system analysis and design, a balanced approach combining technical expertise, business understanding, and user focus. Understanding user focus, success depends on planning, stakeholder engagement, and adherence to proven methodologies while remaining flexible to adapt to changing requirements, and emerging technology. Like I said, you might be running on premise before on prem where the only people that can use the software or anything are people within the office, and they're like, this solution, I think we should do it in such a way that if you are at home, you can use it too. So you will now deploy to the cloud. There are ways that's what you call hybrid, when you have both on premise and you have cloud. That's what you call hybrid. So anybody that is at home can easily access database and everything. There are ways to do all those things. That's when you have VPN and VPC rather, and the likes, and that's where you have cloud computing and all that gateways. That's another thing entirely. So defining the business problem and user requirements. Understanding business problem. You see, this is what you call, let's say, ideation. Ideation means that okay, you want to analyze the existing problem. You know there's a problem, but you still have to analyze it, tear it down. So when you analyze the problem and you analyze the processes, like I said, OPay discovered that our banking app, the sometimes you open it, it doesn't open. Sometimes, and they make sure that was handled on their end, and also the speed of transfer. They discovered that other bank apps is quite slow, and they made sure that they created solutions for that, and that alone has set them apart. Then user requirement analysis, gather comprehensive requirement from stakeholder and end user. What are your problems when you use this software or this application? How do you feel? What are the things that that okay, because of this thing, you are always angry when you are using it? When you ask questions like that, you now discover that the solution you are looking for, that you are thinking of, just talk to people. You will discover that it can be something very small that you will just add to what you are building that will set you apart. And once you have that, you will most likely bite a big chunk or a reasonable chunk from the market size, because realistically, some people love the application the way it is. They will not move to your own. They love it the way it is, depending on what everybody is looking for. Some might even be transfer limits. transfer limit for this is this, so I don't like that. Your own, you just increase it and automatically they move. People with the same transfer that within the acceptable transfer limit will not move. But somebody that wants higher transfer limits will move. So there are some things that there are some little things that if you do your analysis properly, especially users, you're going to get a lot of insights that is going to shape your solution. Then documentation and visualization. Like I said, your documentation is very important because it is what the programmers are going to use to build whatever it is they are building. If your documentation is wrong from the beginning and there's no clear specification and validation with the stakeholders, you can be building for 2 months and the stakeholders' ideas are very different from what you are building. That is going to create a problem. You are just wasting time. So you must make sure that there is correlation between what is being built and the stakeholders and the requirements for the stakeholders and the requirements in the documentation. Because before you get to the point of building, the requirements must have been specified. All the requirements would have been specified in the documentation, and the stakeholders must have agreed. That is why I said do not jump communication protocol, because everybody have their role. Once you jump communication protocol, it's a problem, because the project manager will most likely be the one talking to the stakeholders for these things. And if you now that your job is maybe technical, you cannot talk to the stakeholders. They won't understand what you're saying. So it is the project manager that will be like, this one is better, is good, because when you have relational database, we can. But you that you're technical, I'm an IT person and I understand that it is somehow difficult for IT people to explain things in simple terms. They don't have the time for it. So it is the job of the project manager to do that. Okay, what is the business problem? Okay. So you have three types of let me say documentation. There are three types of definition, but they all have almost similar results, which is an unhappy user or an unhappy person. Performance gap, differences between current and desired organizational performance level. It means that it may be that something is too slow or something is not performing how what is supposed to perform completely. You as the owner of the software or the system might actually think, this solution I've built, it will kill everything. Meanwhile, there is something small that you are not putting into place. If a competitor should pay attention to that gap, you are going to have a lot of problems. For example, I'll give you an example with ERP in Nigeria, because I know from January, because of the tax stuff, a lot of ERP needs to be employed in a lot of organizations. And the number one ERP in Nigeria is actually Oracle. That's SAP. And one thing about SAP is that they don't cater for SMEs, small and medium businesses. Just because they don't cater for small and medium businesses, that means they are not even within when it comes to the number, they are not up to 10% of, they are not serving up to 10% of the total amount of businesses, but they focus solely on very big businesses. So they are making their money and they are incorporated in a lot of things. So they are making their money. They won't even bother to even check if there is a problem. But you that you are stooping low to conquer, you will check these cracks. Now Nigerian ERP are coming up, affordable, and doing certain things to make sure that they get ahead of SAP and they can me, okay, these guys, these are the people they serve. If I can create something that can serve the smaller ones, I think I'll be okay, or I think I can take some market share. Then process inefficiency, bottleneck, redundancy, and manual processes that slow operation. This now has to do with automation. Let me use automation. Let's say, let's use an assembly line, car assembly line. Let's say before, let's use two car assembly lines, Nigerian car brands. Innocent, I don't know any other one, but I know Innocent. Innocent's assembly line, they use robotics and automation. Another assembly line use the best mechanics and the next best motor engineers in the world put together in the assembly line. They should be assembling it. They can never perform as good as Innocent that has automated assembly line with AI. Those ones, by the time they are bringing out 4 cars and 20 cars in a day, you will be bringing out 2. So you need to understand that, okay, what is the process like? What process would create slow operation? What do I need to do to mitigate this? So very important, and it is a problem because it delays delivery. And once something delays delivery, it delays sales. So you need to be careful so that for your sales not to dwindle, you need to get your processes in order. In fact, in blue ocean strategies, there are 2 ways to beat your competitor. First is what you call value innovation. Second is something like this, process innovation. And the reason why process innovation is there is because if, for example, there's a process, there is, like I said, car assembly line. Who do you think will be cheaper in making cars than somebody that is using automation and somebody that is using engineers? Obviously, the person using automation, So now that one person using automation, now because the person is using automation, their cars will be relatively cheaper than somebody using engineers. So now when the two of them put their car on show glass, the person that is saying that I used engineers, you are just talking. This other car is cheaper. There's nothing you can do. You're beating your competitor just by identifying that, okay, this one is using, and you didn't follow them. You innovated your process. Once you can innovate your process, and it leads to lower cost of production. I'm talking of in manufacturing now, because they use systems too in manufacturing. I'm just giving you an example of those that use systems and those that don't when you're identifying business process inefficiencies. Then when you talk of strategic misalignment, okay, technologies or processes that don't support business objectives. This has to do with, let's say, your bank app now, you went to put comments and timeline, turning into a social, that cannot even work, because it is strategic misalignment. A lot of people will not use it because people, when it comes to money, we all know how we all are when it comes to money. And I don't want a place where my bank app is crowded one way or the other. So that will be a misalignment. That will be a very, very big major problem. So you have to avoid that, know what is needed in that sector, like I always say, and user preference, so that you will give users what they actually exactly want. Even if it's not 100%, you are going to get like 70 to 80%, because you need to capture users in the market, and you need to capture people that will use it and use it and reuse. Not just someone that will use once. Use, reuse till it becomes a daily routine to use your software. Very, very important. So you must make sure that your strategy is aligned. Very, very important. Types of business problems. Like I said, daily workflow problem. If you use the manufacturing example I gave, it works with these operational issues. Because when you look at it, workflow, resource allocation, process to process breakdown, that impact productivity. Exactly what I said. You know, if your workflow, if you don't innovate it, you know, you are going to have problem. And if you see that okay, this other person has not innovated his own, once you apply innovation to yours, don't worry, you are already higher than the person just because you paid attention. You know, and any company that does not pay attention is in trouble. Strategic challenges, long-term planning issue, competitive position, alignment with organizational goals. Long-term planning, okay, where do we want to be in 10 years? A lot of people don't. Okay, let me tell you something about Microsoft today. Microsoft, when they came to Nigeria, they did something very technical. They created what you call a workforce. And what they did is that they trained people on their products and gave them certificates. So anywhere those people went to, it is Microsoft that is Microsoft I can use. Is Microsoft before you know their database, everything. That's what people started using. Oracle. There was no other because they had already created a workforce. That's long-term planning. You know, competitive positioning, the same thing. Somebody in the office is the one saying, Microsoft can do it, you know, and it also aligns with the organizational goals because what is the issue? Okay, this is the issue. Does the solution solve the problem? Once the solution solves the problem, and that is it. And this strategic challenges too has a lot to do with the 4 Ps, the price, product, people, and place. So I think that's for another um, time. Then we look at technical problems, system integration issues, architect intelligent infrastructure limitations. You see, this now system integration issue, I said it before. You want to integrate something into that's why I said Android phone now that's running, let's say iOS 11, and you're and with that you just shot yourself in the leg. So you must always make sure you mitigate for integration, and you must always also make sure that you mitigate for. Please, can you hear me, please?
Yes, we can hear you.
Yes, we
Can
can
hear
hear
Okay,
you.
okay. So you must always make sure that you put in place the integration issue. Make sure that you are sure that okay, this thing that we are doing, will it apply to a lot of devices? Very, very important. If not, it is yourself, it is you that will chase yourself out of the market. Because if your products cannot be on so many devices, then there is no point in creating them. Your product should not have a lot of requirements for it to work. Once it has a lot of requirements to work, is a big problem because even you and I, if you download the software now and it will have to take you extraordinary brain power to make it work, we all know we will leave it. So that alone, that portrays this technical problem, outdated technology. Maybe people are using SQL version 10. You now decided to use SQL version 5. And that SQL version 5 now has issues. Then you are using it, the issues, you have to be handling the issue. And maybe there's a vulnerability and an hacker asks you, you are in problem. Now, another company now is using the latest one. The performance will be very different and they will outsmart you. And likewise, the company is using an outdated technology. You are coming up with a new technology and all of a sudden you've taken over. You know, it's just like Google and ChatGPT. Basically, they almost do the same thing, but ChatGPT is very, very specific. You know, making Google look like an outdated technology, basically. But Google too had to do what? Move fast to create Gemini. So it now became an AI war. You know, even if Google is not really keen about AI, they still need to create it to be able to compete in the market. If not, nobody will even go to google.com. You know, people will just be going through AI. What you just before Google, you ask Google all the questions. Now you don't even have to ask Google all the questions. You can ask ChatGPT your questions. See that has already created, that's already divided Google's market share. Because if 100 people are going to Google normally every day to say what is A, now you have at least 50% going to ChatGPT to ask the same question, and ChatGPT will give them a more refined and specific answer than what Google will give you. So it's already a problem for Google, you know, and that's why they had to create their own Gemini AI, you know. Okay. Problem identification process, symptom recognition, identify visible signs of problem by like declining performance or customer complaint. Like I said, if customers are complaining that I want this thing to be like this, why is this thing not like this? You have to listen and you have to make correction. That's why I said Bill Gates said it then that your best customer is your most valuable customer is your most angry customer. You know, because they are the ones that will tell you that this thing is wrong. Then if there is a decline in performance and that's where the monitoring, like I said, business intelligence, you are seeing your sales, you are seeing everything. Okay, there's something wrong. You can know from there that there's something wrong. I'll give you an example. During Big Brother, my mom wanted to watch Big Brother. So I was supposed to do subscribe for Showmax for her. So I got the account, and when it's time to pay, their payment system had issues. How can you, as the software, everything is working except payment? You are not serious. Every other thing, when I want to give you money, you are not like, keep your money. There's something wrong. Then you are not serious, because that should be, in fact, if that's the only thing working in your application, it's still good. But that was now the one thing that was not working. So me, I was like, well, these guys are not serious. Later it was addressed, but at that time I wanted to pay. It was not available, which is not it at all. Then root cause analysis. Dig deeper to find underlying causes rather than just addressing symptoms. Now, you see this is, I will take it step by step. System recognition is where you know that, symptom is when you know that, okay, there is a problem. Root cause analysis is when you are not like, okay, let me analyze this problem, these symptoms, and know the root cause of the problem. For example, the problem might be as little as maybe when it might be a database schema. Maybe when you do something, it stores the data somewhere else that is not supposed to store. That is what's creating the problem. It can be anything, you know, and before you can find it, you need to do, it might not create error, because for IT people, the only time they can really solve your problem is if there is an error. If it is working properly, it is very difficult for us to know what is wrong, except an error is initiated. It is now the error we will use, but there are sometimes there is a problem, but there is no error. So you have to now do root analysis that, okay, this thing they are saying, what are the codes that function here? So you have to do your analysis to know what is wrong. And we are going to see more of that in the practical section, where you see how I built something with all these principles. Then you go to problem validation. Confirm the problem exists. Okay, when you check it, when you now do your analysis, okay, this thing is true. How it is happening, it is not supposed to be happening. Because sometimes user complain might not even be your fault. It might be them that don't know how to use it. They can tell you that this thing is not clicking, they are not clicking it. I've worked in IT support for 3 years, and I worked in 3 different places for those 3 years. And I can tell you something for sure, that sometimes 70 to 80% of the problem is the user that does not know where it is. You know, then when they now call you, they will say it in such a way that the whole system is bad. and that's where you now have to now do, okay, what is the problem exactly? Is it them or is it the system? So once you confirm the system exists, the problem exists, then you have to work on it because it will affect the organization. It will affect, once it is a confirmed problem, it will affect an organization. And even if it is a user problem, you still have to address it because you, like I said, you don't want the user to come online and say, I use this thing, look at it, they did not answer me, they did not do this, they are very bad customer support, this. It's problem for you. Because you cannot go online and be saying, it is the user that does not know, you are creating more problems for yourself. Bad PR. And you don't want that. So you must always confirm the problem exists and take care of it. Very, very important. Create mitigation strategies. Okay, this is this, and you solve the problem. But if it is the user that has the problem, then your customer support can talk the user through what they need to do. Very important. But root analysis is second after the problem has been recognized. Then when you now discover that, okay, if the problem is not a problem, then you decide what to do. But you must always take action, either by solving the problem from the back end, or if it's the user's fault, this is what you're supposed to do, this is where you're supposed to click, this is where you're supposed to click, then everybody is happy. Stakeholder analysis. Executive sponsor, senior leadership will provide strategic direction and funding approval. Now, these executive sponsors come in two ways. You have the sponsors, only works at the beginning. It is investors that work once it's built along the software timeline when it is out. Because obviously, to start building, you need money to buy server space, to pay for API, to pay for plugins, services, microservices. You need money. So the leadership are the ones that are going to provide the money. And they are the ones that are going to provide, like we said, the business that you want to translate into a software solution. Now, external customers. End user, end customer whose needs drive system requirement, and functionality. Obviously, like we were saying, don't build just because you are passionate about it. Don't build what you love. Build what people love and sell it with the language that you know they will connect to. For example, when Steve Jobs wanted to sell the iPod, just one phrase killed it all. He said, imagine 1,000 songs in your pocket. That was all. There was no, he didn't even have to say any of that. Though that kind of line cannot work now because obviously our phones can have 1,000 songs. But then it was an iPod that could do it. And he just used that statement to sell it, that this thing solves your problem. And what was the problem then? Anybody that wants to listen to music on the go, you either have a Discman or a cassette player with earpiece. But he now brought a solution after discovering the problem. Okay, and how did he discover the problem? It was his daughter. His daughter was always working with a Discman. So he was always angry that this thing is very big. Why are you holding it like this? And he told her that I will create something for you that you don't have to be carrying this big something. And that was how iPod was created. And I sold it, imagine 1,000 songs in your pocket. That was all he needed to say. And he got the functions and the requirements complete. Once you have that, then you have your end users, daily system users who understand operational needs and workflow requirements. You see, for end users now, end users are not really emotional people. They are very emotionless because that is their job, to use your software. And once it doesn't perform what it's supposed to perform, that's the end. Because you see these particular end users, when you say daily system users, it comes in two forms. For example, not everybody operates POS. The end users for POS are very different from you and I, in the sense that it is POS business people, POS people that want I will handle POS. If they give me a POS system now, it might take me an hour to understand it, because it is not my thing. I don't operate it. Now, it will be very, very, it will be very, very in I don't know how to put it, where they will now be asking me for feedback for POS system, and be asking me for workflow requirement. Like, you can't ask me because I don't use it. You have to ask the POS, even though the POS user served me, you cannot ask me for that feedback because I don't know what to tell you. I don't use POS. So you must always know the users that you want to ask these questions, because anybody you are asking, for them to give you a valuable feedback, they must also understand the operational needs and workflow, because they are the ones using it to make money too. So that's why I use the POS system, because those ones now is there's like a segmentation of the end user and the vendor user, which they are, so they understand the needs more than the end user, because me and you don't need to know how the POS works, but they need to know. And if they want any feedback, they are the ones they will have to ask. The IT department, yes, like I said, keep your team very close because of maintenance and implementation. See, it was mentioned here again. Technical teams responsible for system implementation and maintenance. See, very important, because if you don't have them, if anything should cough, you will just be running. See, you might think that you're having a very peaceful day, chilling. You're in the beachfront, looking at water, everything is going fine. You can receive 10 calls in 1 minute just because something is down. Obviously, the users don't care if you are the one doing it or not. It's you they know, and you are the owner. It's you they will call. Now you have to now call the technical team that what's up? People are saying the system is down, blah blah blah. Imagine you don't now have a technical team, or you pay them you do payment per work. Then you now say I'm busy, and they are calling you like that. So you must always take care of your technical department, the IT department. Very important, because when you build the solution, you as the owner or the stakeholder, you have to go and look for new businesses for it. You cannot rely on marketing alone, or digital marketing or digital branding. No, you have to use your leg to go to places, get partnerships. But then the IT department makes sure that it is working fine and make sure that they are duly compensated for whatever it is they are doing. Very, very important, because they are the ones that will handle the back end, the pillar. They are the ones that will handle it. And it happened, though the one that happened to Mark Zuckerberg was a little bit different. The other guy that was working with him withdrew his support and the server went down. Then he quickly got an investment from somebody that brought it up. So you need to make sure you take care of everybody responsible for the system to be up. Very, very important. If even there are some times that somebody will leave a big company, he's part of this company, he will leave just because he's not happy with something that maybe the CEO or the board of directors are doing. He will go and create something else that is similar to what you are doing, and you will now use the complaints that you are complaining here to go and build it. Then you will now surpass those ones. You will now be wondering why, because those ones are not following the actual steps. One, two, they are not taking care of their IT staffs. WhatsApp IT staff, for like 5 to 6 years when WhatsApp started, they were not making money, but their staffs were with them, very loyal. They were using this disc recorder that they used for this olden days movie that used to spin. That was what they were using to store data, text data. and they were doing it, they were replacing it manually. The kind of server that was available then was not like now. And these people stayed with them, not because they were paying so much. In fact, they were not making money for the, I think, first 5-6 years. But these people stayed with them because they were treating them well. And when the money came, they gave everybody. When Instagram bought them, they gave everybody what they were worth. They made everybody millionaires in dollars. And that is what it takes. And likewise, Mark Zuckerberg, he was sued by that same guy and he had to pay that guy compensation. I'm just giving you the difference in how the result when you take care and when you don't take care of your. There are so many companies that has gone down because they didn't take care of their IT staffs, and a lot of problems we're having in the IT industry in Nigeria is actually because of skill gap. When you have an IT staff, you tend to be paying them peanuts. Somebody comes from America and says, I'll pay you times 10 of what they are paying you. Nobody will stay and they leave. Then you now have to now get somebody that is not as good as that person, that does not even know the system as that person. Then it becomes a problem. Something happens, it will take a longer time for the new person to solve it because he's not yet conversant with the system. And trust me, problems will arise. That is not even problems will arise. Requirement gathering techniques. You have the interview, you have the survey, and you have the workshops. In the interview, one-on-one discussion with stakeholders to gather detailed requirements and understand perspectives. For example, if you want to build a stock market system, you cannot go to a chef. You cannot even come to me. You cannot go to a trader. You have to go to a finance person that does the stock market, that deals in stock market. They are the ones that will tell you, okay, this is what you want to build. Okay, these are the problems that we think are in what you want to build. And you must have a professional in that field before you can say you want to, because they are the ones that will tell you the things that is required. For example, it was when I joined the team to build something of fintech, I knew that you must even have data collection, anti-laundry. When CBEX happened, I heard of anti-laundry, but I didn't know why you need it. But when I joined that team, I now saw why it was needed. Because if CBN is going to put you in charge of people's money, they need you to commit that I will not launder, I will not, and I will protect their data. That is why you need these things. So it is a way to, so these things now, you might be building and you don't know you need these things. And you finish building and you want to deploy and you see that they don't allow you or they sanction you, which is the same thing I think they did that to Paystack of recent when they released SAP, that the government fined them 200 and something million naira, I think, because they don't have the license for what they wanted to do. And the license was, they don't have the license to hold money for people. As small as that sounds, they didn't have it. I don't know the game that was played between them and the government, but they were fined for that. And I don't know if they paid or not, but that aside, then surveys and questionnaires. You see, for different sectors, you need different approach. You might need two approaches, or you might just have to do with one, or you use the three, depending. Then for survey and questionnaire, that's why I mentioned the football app, where you go and you be like, use this app for a while, or if you've not built, you can go with just questionnaire. That would you, okay, let's say you want to build a streaming IP, there's what you call IPTV. You want to build an IPTV for just football lovers. And you ask that what you want to know if they would use it, and you want to know if they will use it. Then you go to a bar, you see the passionate ones, you approach them. Hello, I'm building this, I want to build this, and I would like to know your opinion. You give them a questionnaire. Would you love to watch this match in your house? If yes, how would you love to watch it? You start asking questions, then they start giving you feedback. The truth is that no matter how many people you see in bar, there are still a lot of people that watch online. A lot that watch online. So there are so many ways you can ask your question. You can go to WhatsApp groups, and get your data. Once you have your data, you are good. Then you analyze the data. Okay, what do people really prefer? Then you build towards their preference, because you cannot satisfy everybody. So you try and satisfy most people as you can, as much people as you can. Very important. Workshops, collaborating sections, bringing stakeholders together to define requirements and resolve conflicts. You see, for this last one, I remember Konga. Is it these other guys that used to show movies before Netflix came? I've forgotten their name. They got investment and they got um, a lot of marketers to be marketing for them, to be called guerrilla marketing. They go out, make people download the app to watch movie. I've forgotten the name of that um platform, but it's a streaming platform. And Netflix came. What did they do? They just went to the movie producers, the um Ebony guy, the Ebony lady, and Sunua. They just went to those guys. Afolayan, they just went to those guys immediately, and they partnered up with those guys. What do we need? And before you know, movies started coming out, Anikulapo and the rest. Even if there is a little bit of issue in that area, and they started before you know, the Nigerian guy was dead on arrival. He couldn't compete because those guys collaborated. They collaborated while he was just doing things that he felt he needed to do. While them studied the market, knew that okay, what's wrong? What is actually wrong is quality and finance for execution. And they collaborated, they beat them immediately. There was not even two questions asked. People dropped those ones immediately because something that's why users don't really have emotional attachment like that. Once this one is better, they go for it. It doesn't even matter what you that owns it, how much you love your software or how much you love your solution. They don't care about that. Is what they care about is, does this solve my problem? Once it solves their problem, you are good to go. But if it doesn't, there's nothing you can do. You can't beg them to use it. And that's the way it works. Okay, advanced requirement techniques. Okay, job shadowing current user. Job shadowing current user. This now involves you looking at everything still boils down to observation, more or less observing somebody using it. Somebody using it. Okay, how is the person using it? Process observation and documentation. What is the process like? You see, this process, observation and documentation, when I was working at the hospital, the consultant doctor said something that he wanted a system that will be paperless. That means people will sign with a pen digitally, and their faces will be captured digitally. And we needed to work with the people that created the EMR to create that solution for us, because we've seen that is a problem. We cannot keep storing paper. So we have two branches, one in Abuja and one in Lagos. So the Lagos one was a new branch, while Abuja has been operating for years. So they now called a meeting between everybody, and I was there, and the other IT people from Abuja were there. So when they were discussing on what to do, I noticed that a lot of the IT guys were not obeying a lot of these principles and methodologies. And me, I understand something, that when you want to build a system, you have to count the amount of processes. For example, somebody walks in, The first process is the grit. What do you want to do? If it requires you filling form, you give them a form. Second process, they fill the form, they write their name. The third process, you fill it into your system as the secretary or as the attendant, the hospital attendant, into the system. That's the EMR. So they were saying a lot of things around that. I was not like, why don't we talk to the EMR guys? Let them build a mini version on our server that we can be using that will contain where people will sign and photo. These guys told me that that no, that my opinion is actually not needed in this conversation, and I kept quiet until today. They didn't get that thing done because what they were saying cannot work because it will take a lot and it will not actually solve the overall problem because they were looking for something that they will call that will require a lot of money that they can chop from. Me, I was looking at the process, that how can we minimize the process from before till now. If the process was 4 before, we should at least make it 3 now digitally, because if the process was 4 before and it's still 4 now, there's no difference. It's still the same thing. So I came up with a plan. Let's do this, and they didn't do it until now. They've not done that solution. So these techniques are actually very important to obey, because just obeying them alone gives you a very, very good and applicable result. Now let's look at documentation analysis. Existing system documentation. When you read existing, that's why I said that, okay, what are the processes before? If it's 4, let's do 3. Business process manuals, regulatory requirements, historical data analysis. The historical data analysis, how has it been done before? When it was done this way before, what result did it give? Okay, there's another method that was used elsewhere. Okay, how was it? Depending on what you want to do. How was it? Okay, this is what it means. So all those things now is something that people will have to sit down. This business process manual, in that same place, there was something that happened. We're doing an outreach. Over 400 men were supposed to come because it's a prostate hospital where they treat prostate enlargement and prostate cancer. So they wanted to do outreach for 400 men. And they told me specifically that we don't want to use paper. Everything has to be digital from the registration. So I created a Google Sheet and logged it in on all the departments' system. And if 10 people are coming today, put the 10 names and put the dates behind every sheet. Put their names, the lab, arrival, lab, the X-ray people, and I put everything. So when somebody arrives, write arrive, write is in here. So there are so many things so everybody was seeing the progress of everybody. That was a business process that was really good, and it really, really helped because it made a lot of things easy and it made us to manage a lot of people, easily. So if I want to do something like that again, obviously looking at historical data analysis from my own history of things that I've done, I know I have to do the same. Regulatory requirements is different for different industries. Like I said, for fintech, you must have EFCC anti-laundering certificate, data protection certificate. You must go to CBN to collect. So regulatory requirements is also important. If you don't have those and you build the best software, there's nothing for you. You're not going anywhere. You need to understand the regulatory requirements for that system, and you must follow it. Very, very important. Types of requirements. Functional requirements. What the system must do, specific features, capacity, capabilities, and behavior. For example, a bank app that cannot transfer money, there's no point. It's very simple. A bank app that cannot transfer money, there's nothing it's doing, there's no need. That's why it's called the bank app. Then non-functional, you have the speed, security. Now for this, now there are things that you don't notice, but if they start having issues, you will notice. But there are things that, at least functional requirements, you notice it because they are very practical. Non-functional and not practical. It's just like you logging into your app. You won't bother yourself if it works. So this one, the non-functional, you don't, most of the time when it works, you are not bothered. You don't even know it's there. The moment it stops working, that's when you know that there's something wrong. But for functional, it might still work and you might not still like it because of the way it's working. For non-functional, you won't even know it's there, but the moment problem comes, that is when you will realize that, okay, there is something actually wrong. Then for business requirements, like I said, you cannot create a banking app and it's working like a social media app. That doesn't work. It will not work. So you need to know the requirement, business requirement for you to make money from it. Very, 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 very important. And business requirement is tied to function and user satisfaction. Because if you cannot satisfy the user in the business aspect, nobody will pay for it. They will not pay for it. They will rather leave it and go. There are so many apps now that require you to pay, and you and I know once you see it, you leave. Okay, that's because it is not a must. You pay for, so you must make sure that anything you are building meets business requirements. That this thing, if I put it there, do they pay for it? I want them to pay for it. How will I do it that they will pay for it? And make sure that your first two, functional requirements and non-functional requirements, are intact. If not, no matter what business you have put, no matter the function, nobody will use it. Okay, functional requirements is that user action, specific tasks user need to perform within the system, such as data entry or report generation. Now, like I said, functional requirements are things that you do, they are practical, very practical. So if they are not working, or they are working, but not in the way you want, it is still a problem, because they are very practical. For example, you might want to, for a bank app, you might want to export your entry when it comes to, you want to export your log, that's your transfer history, and you discover that the amount is missing and everything. It's going to be a problem. This cannot work, or you try to generate it, they are telling you error. That is going to be a very big problem. So system responses, like I said.
Sorry, sir. The class should be ending in less than 30 minutes. That's 2 p.m. Are we still going through practicals?
We are supposed to go through practical, yes.
Okay, because the class is to end by 2 p.m. So.
Okay. Okay. Okay, let me be quick about it. So for system responses now, how does react to user input? Like I said, you want to transfer, you're transferring 5,000 and 10,000 is leaving your bank balance, or you send the money, there's no success message. So that will create a very, very big problem. Business rules, organizational policies and procedures that must be enforced by the system. That was when I talked about the login. When you log into a bank app, once you leave it, you're supposed to close the session. Once you don't do that, it's a very big flaw. And someone can just pick the phone and just go. Once they know that, oh, GT does not log off the person might not talk, might just take somebody's phone and will just check, calculate, okay, the person has logged in, went off. will just go and do something shady. Yes, that can happen if you don't fulfill those requirements. Data management, requirements for storing, retrieving, and manipulating organizational data. This is also very important. That was where we talked about database schema and the types. Each data set would have a particular type that must correlate with the input. Numeric should have numbers, alphabetic should have alphabets. Alphanumeric should have both alphabets and numeric. Very, very important. Then you have non-functional. Like I said, these are things, they are not practical and they are there. But most of the time, when they are working, you don't pay attention. Response times, throughput, that is in and out, in communication and output communication, system capacity under various those conditions. Like I said, 1,000 people come into your app once. Is this realistic carry it? Realistic work? Security, authentication, like make sure that, like I said, for this authentication now, like the person types username and password. Once the person leaves, make sure that the session closes because of it depends on, for example, now for social media, you don't need that. You need the person to still be logged in. But for bank app now, you need the person to close the session once the person logs out. So every business needs or every software you are building, there are different security security um security needs. Then usability, easy to use, where everything is supposed to be is there. Login is below. Username and password. Password is not in one place. Username, no. Everything is how it is when you want to log in into a system. Requirements documentation. Detailed document outlining all functions and non-function requirements with clear acceptance. This is the documentation I talked about. At the beginning, there must be a clear documentation of everything. And the documentation contains user story too, and it contains use cases, because these are the things that would allow the programmer to be like, okay, there's a specific task and this is how the task was documented and this was how it was done in the document. How can I create a code base, or how can I code this experience? You know, so that is the use cases. Then for user stories, brief description of features from the user's perspective, often used in agile development. Now, user story, okay, you have to talk to maybe somebody using something similar and be like, okay, in this app now that you're using, what do you enjoy the most? Okay, this is what you enjoy the most. Okay, you add it. What don't you like? Okay, this is what you don't like. What do you need? So those are user stories. Use case development. Actor, person or system interacting with the system. Goal, what the person wants to achieve. Precondition, what must be true before the user case starts. For example, if you are transferring money, if you have zero balance, obviously you can't transfer. That's what precondition means. There must be something available before something else can work. It can also be what you call trigger. In a longer workflow, but you understand when I mean if you have zero balance, you cannot transfer. That means having balance is a precondition for you to transfer, and you must transfer lower than the balance. All these are also preconditions. Main flow, step by step, normal scenario. That's where you have use cases where you see how they interact to come to perform specific goals. Alternative flow, this one talks about, let's say there is an error in what you want to do. What other option did you give the system to follow? For example, if your errors are not handled well, once there's an error, the system from the default is supposed to crash. It's supposed to actually crash. But there is there are some times where when the error occurs, there's a code that you tell it just take it to the home page. Then it goes to the home page. It doesn't crash. So there are different ways to mitigate error conditions. Then post condition, like I said, if you transfer, does it say successful or not? So they gave an example here of the whole process. Actor, customer wants to access the accounts. Okay, precondition means that he has registered an account. Flow types in username and password, and if it is correct, the user is authenticated and the user is allowed in. That's a very simple analogy. Requirements validation process, review session, structured meeting with stakeholders to review. I think we've done this review sessions, talked about it, creating mock-up needed to validate understanding and gather feedback. We've done something like that. We've discussed it, accepting criteria, defining measurable conditions that must be met for requirements to be considered complete. I think we've discussed that in Agile too. Common challenges, creep, uncontrolled expansion of requirements beyond original project and leading to delay and project. Yes. In as much as you want feedbacks, you must always, or you must put into consideration that you don't want to do so many activities without a clear goal, because it is very easy to get feedback to the point where you can mistake your goal and start doing something else entirely. So you have to control what is being done and project boundaries. Very important. Conflicting requirements. Different stakeholders may have opposing needs or priorities that must be resolved through negotiation. This one now, it is probably most likely the project manager that is going to resolve this, because A can say, I want, stakeholder A can tell you, I want this. Stakeholder B can say, I want this. They might not even know that what they are even saying is opposing. But the person writing the code will be like, this is like looking left and right at the same time. So there must be a way to resolve that. And that's what that conflicting requirement means. Unclear specifications, ambiguous or incomplete requirement that leads to misunderstanding. You see, these unclear specifications occur when there is a flaw in the initial documentation. When there's a problem with the initial documentation, a lot of things will be unclear. You will just be doing a lot of things you won't know. And if the stakeholders should see the product and be like, this is not what you want, you have to start again. Changing business needs, evolving organic priorities that require updates through the project life cycle. Now, something might happen and might need you to change how, for example, they might say, CBN can say, okay, the daily limit for transfer we want is 10,000. Meanwhile, inside your app, your daily limit is 100,000. You have to do something about it as fast as possible. You have to, because if you don't, you'll be sanctioned. They most likely always give a date for implementation before they start watching you, but you have to do these things. So you have to know what is required in that your field so that you won't get into trouble. Because the reason why an organization will actually obey most of all these things is because of two things. Number one, government's requirements. Number two, user requirements. Sometimes it might not be users that require you to do it. It might be the governing body. And because you feel the users love it and you don't listen, they can sanction you and you're going to pay a lot of money and you will eventually end up doing it. So you have to be careful. You have to understand that changing business needs, very, very important. Requirements management, traceability, linking requirements to business objectives and tracking changes throughout development. Yes, you see, this now is a back-end something. You must always make sure that is where you have GitHub. GitHub is where you commit your projects and it saves your changes and it documents them for you. You know, each commit you do, your commit you do is more or less like uploading your code. So it will now, GitHub will now be like, okay, in this last code, this new code you dropped, these are the things that are different from the last code. Version control means that, let's say, last month I did something, I made the login button blue. Next month you said you want the login button to be red. So I'll when I upload the new, when I do it and I upload the new code into the server, a version of the old one, the one that it is blue, will be kept. It will not be destroyed. It will be kept. While the new version will be the one running. In case there's an error with the new version, you can do what you call rollback. When you roll back, you now roll back to the previous version that was working. So that is what version control is good for. Prioritization, ranking requirement by business value and complexity. This means that, okay, what and what should I do first? What is easier to do first and what is harder to implement? That too matters because it helps you in time and task management. Very, very important. Tools for requirement management, documentation tools, like I said, Microsoft Word, where you put all your documentation, modeling tools. These are tools where you use, where you, and I have something like this for us. Modeling tool is when you draw maybe your wireframe, your wireframe, and that wireframe includes all the pages and everything that is required. That's what you call modeling tools. And sometimes it's also used for task. You know, what are the tasks? What are you supposed to do? Visual. Once there's a visual um, representation of the requirements, you can now place somebody on each requirement. Okay, this is the person that is responsible for this. This is the person that is responsible for this. So the person knows what to do. Okay, collaboration platforms. This is where the project manager, like I said, project management comes in. These are the platforms that the project manager would use. Now I mentioned Slack. So Slack would appoint tasks to each person. Then the stakeholders can see, okay, this person is supposed to do this. This person has finished this set. This person is doing this. So it requires, it tracks everybody's activities, what has been completed and what needs to be completed. Okay, best practices, clear communication, using simple language to, like I said, the project manager is the most expert in clear communication because he's one that knows how to say, to convert the technical words into simple things that the stakeholders will understand, you know. And he will also translate the stakeholders' technical business words to what the programmers will understand. Comprehensive documentation, like like I said, the documentation be it must be it must be comprehensive enough for the programmers and the project manager to work with and the stakeholders to understand. Stakeholder involvement. You must engage all relevant parties throughout the requirement gathering process because if you don't, one person might come and say no. Remember this. The other stakeholder will be like, ah, yes, that's true. Project manager, you have to go back and do your assignment. So you must make sure that you talk to everybody and get everybody's input because these guys, these stakeholders don't know how long, don't know the technical know-how. Their own is those simple English. We want it to look like this. We want it to do this. They don't know the technical. So you must make sure you meet all of them because you know the hard work that will be done if one person is not involved and the person comes later and says, I want you to do it like this. And maybe you guys have moved past that stage. You have to go back. Very, very, very important to talk to everybody and put everybody's account into consideration. Iterative refinement, continuously review and refine requirements based on feedback and changing needs. Yes, like I said, you must always make sure that you are refining as they are telling you to change things, you are doing it as it is being said. Feedbacks, everything, you are refining everything, you are changing, you are improving, you are innovating. Early validation, yes, validate requirements early and often to prevent costly changes later. And this has a lot to do with maybe database. When you set up a database schema, you must test if it is giving you what you want before you now start building on it. Because if you don't test and you build everything and it doesn't work, you have to go back. So all these things are very important. Anything, any system you are building from each stage, make sure that they work. Because even if you make sure they work at that stage, when everything is being built, the behavior might change due to one or two dependencies or one or two processes. So make sure you get your validation early. Very, very important to know that, okay, what I have implemented is working. Okay, success matrix, requirement completeness. Okay, 85%. So what they are saying here is that the requirements at least must be 85% complete, you know, before you can say, okay, you are doing something, or I've done something, or you have a result that is manageable. Because, and the reason is, at least they are sure that most of the requirements or most of the functions are complete, and they will do what you want them to do. Now, for 92% stakeholders, because they are the ones paying and they are the ones that are going to bring in new businesses, they need to be happy with what you are using. They need to say, okay, this is what we want and this is what we can sell and we can defend it outside because it is from us, something like that. Change request rate, percentage of requirement by requirement modification during development. So what this means is that you should try as much as possible to minimize change rates when development is going on, because it will slow down development. You cannot say I want A, B, C, D. Now, after 2 weeks, you will now be like, no, I want D, E, F. They will now remove A, B, C, D, then put D, E, F. So you must make sure that all changes are very minimal and effective so that you can meet deadline. If not, you will not meet deadline because each changes requires time. Key takeaway: foundation for success, well-defined business problems, user requirements, foundation for successful information system projects, stakeholder collaboration, effective requirements gathering requires active collaboration with all stakeholders throughout the process, continuous management. Requirement management is an ongoing process that continues throughout the system development lifecycle. All these things, I believe, I have actually explained them thoroughly. Technical design, methodologies, and practical applications. Exploring systemic approaches to create robust, scalable, and maintainable information systems, proven design methodologies. Yes, this was what I was saying about obeying the rules. You must obey the rules so that you can get the best results. If you don't obey the rules, you just, except you want to create your own rules, and that will take time. And most of the time, you don't do that during development. You do that on your own. Then you can now apply it to test, then deploy. But to make everything work fast, you must obey the rules from the beginning. What are technical design methodologies? Systemic approaches, structured framework that guides the technical design process from concept to. This is one I was talking about, the on-premise or the cloud. Which one should we use? You know, on-prem, you don't need any other person, just people in the office. Okay, that means to be on-prem. But if it's cloud, you need people in the whole world to use it. You know, for example, if you are using cloud and you want to serve somebody in America, what you just need to do is provision a server in America and create an access list control where or IPA filter where only Americans. If you notice, that's what they do for Netflix. There are some things we don't see in Nigeria, but they see in America. It's because the server that they provision for Nigeria and the database of movies is different from that of America. So when you go to netflix.com, it checks your IP address and determines your location and provides you with the specific geolocation specific servers. And that's when you now get the Nigerian. There are other ways to check other countries' Netflix, but that's for another time. Best practices. Proven techniques and standards that ensure quality, maintainability, and scalability. Very important. Like I said, don't do anything brand new, especially in coding and implementation. It will affect you. Work with the best practices first to get your results early enough. Then, when you want to innovate, you can now start doing that on a test. But do not do I am skillful on live. You are going to break the system because you have not validated it. Problem solving tools, methods that help developers tackle complex technical challenges systematically. You see this one now is you use what you call console for console is the most commonly used problem solving tool, which will tell you your error on your browser. There's a way it works. It will give you your error, but now those errors now they are easier to mitigate due to ChatGPT. Before, once there's an error, you search the whole of the internet for it. No coder does not search the internet. Everybody searches the internet. If you're an IT person, the internet is your friend. Google is your friend. But right now, AI is your best friend because it will streamline your problem and it will solve it for you. It will follow you through till you get it solved. Why technical design methodology masters consistency ensures uniform approach across development teams and projects. Like I said, don't think of anything new. Don't say you want to write something new. Don't follow the process so that everybody, because what you are writing that is new, the other person might not know it, and which means it will slow the other person down. So you must always follow the best practice so that you guys can move very, very fast. That's why if you notice, they will say which is the best language to use and all that. People just focus on the language that a lot of people know and a lot of people can work with. And with that, you are good. That's when you have the Java and the JavaScript. You know, there are so many languages, but how many people know them? Don't build on a language nobody else knows. And you will not start getting worried. And if that person should leave, you have to go and look for somebody that will do it, which is very bad and can be strenuous. Risk reduction minimizes error and technical debt through structured planning. So once you adhere to these methods, your errors will be minimized because you are following a set of rules. You are following a set of rules which is structural, and these rules have actually been proven to be correct. So you now changing it or doing something else, you put a strain on the whole team because it is very important you follow through so that you know that any error you're having is an error that is common or someone has had before, not something brand new that will slow everybody down. Efficiency, streamlines development process and reduces time to market. Like I said, these methods have been proven to work. So it streamlines your process. This is what you need to do here. This is what you need to do here. You don't need to do anything extra. You don't need to do anything out of the box. Just follow through first. Anything out of the box should be done in your test environment. But if you are building initially, you must make sure that you follow the rules so that you can get your results. Then scalability. Like I said, create systems that can grow and adapt to changing requirements. Now, that also means that's why I said that 100,000 people should come now to your software release stand or release for. You must always ensure that, okay, this system I've created, there's room for expansion. There's room for user expansion. If users should flood today, will it stand or will it not stand? You must always make sure that when you are building these systems, you are putting scalability in mind. Very, very important. Wow, object-oriented design. Now, these terms now are mostly programming terms. Encapsulation, binding data, and the methods. That's when you sorry, I'm not a guru in programming, but I will try as much as possible to explain.
Sorry, Mr. Toby. Okay, so the thing is, we'll be having a continuation of this session by next week.
Okay.
Maybe we can just round up and have the practicals by then. So it's 2 p.m. already now.
Okay, let me stop at structured design methodology. So when next we're having the class, we'll continue at agile. Is that okay?
Yes, that's fine.
Okay, core principles, encapsulation. Encapsulation literally means, it is a very practical word, in the sense that it's something you come across when you're coding or when you're writing coding, and it has to do with when there's what you call methods. Methods are written instructions, and these instructions now are meant for objects. What object means is, let's say you have a button. A button is an object, and the method is what determines what that button does. And combining the data and the method is what we call encapsulation. And the data can simply mean, if you click it, it should do something else, or it should bring something. So that's what encapsulation means. Inheritance, you're using code through hierarchy, means that, okay, let's say at the beginning of your code, you wrote a set of code to do, let's say, to transfer certain things. In order for, let's say, you're now going down, maybe you wrote the code at the method at line 20, and the method stopped at line 26. So that's 6 lines of code. You now want to call on that code again, or call on that same function. Instead of you to rewrite the code, you can just do what you call inheritance. You call the code by its method only, instead of rewriting everything from the beginning. So it helps you streamline your code so that it won't be too much. Polymorphism is when you have multiple forms of behavior. That means this helps in error handling, where if something does not work well, or there's an error in a particular operation, do something else. And if there's an error there, do something else, but the application will not crash. It will not crash. That's the essence. When there's an error, it will not crash. But because most poorly implemented codes will always crash, because once the system cannot go on, the process cannot go on, it will terminate everything. So there are ways to do it that it will not terminate. It will just maybe go to the home page or tell you error. Once you click OK, it will reset back to that page, and it will just wait for the next instruction. Then abstraction, hiding complexity. This now, maybe you wrote the code, a very huge line of code somewhere within your app. Because you don't want your let's say index to be too cumbersome, you write the code somewhere. You will now call it. I will show you. There's an example of this in my practical. You will now call the code. You will call that code from your home page, from where it is to your home page, but you will not write everything in your home page. But it will work in your home page as if it is written there. So that's the advantage of abstraction, and it helps so that you can finish a lot of things easily. And this abstraction really helps when you look at server side coding. When you configure your server, you put it somewhere. Your server credentials, you put it somewhere, you put everything somewhere. Then you call the authentication, everything in your login page. But the coding for your login page, you don't see it in the login, but it has been called from somewhere else. So that's an example. Then the benefit of using these principles promotes code usability, maintainability, and modularity, makes complex systems easier to understand and modify. Structured design methodology, top-down approach. Yes, break complex problem into smaller, manageable components. Now, what this means is that if you want to build the whole system, like we said, you want to build, let's say, social media app, you will log in first. You have to now say, okay, as I'm building this thing, login will be first. Once login is successful, you now put, okay, user the timeline. But let's say the person is registering. Once the person registers, is the person going to fill their profile? Are they going to, there's a workflow, so that once you start designing and coding, you will be coding according to that flow. That's what it means. Then create independent modules that can be developed and tested separately. That was where I was talking about creating a test environment where you will do anything you want to do that has to do with creating new things. When you are looking at the main work, you don't just create new things. You can have a test environment to create new things where you can now test, but you cannot be doing it on your main this thing, because the people you are working with might not understand what you are doing, and you make the work very slow. Hierarchical structure. Organize components in logical layers with clear dependencies. This now, when you are coding, especially in certain languages, you have to import certain things. Now, if you don't import those things completely, or you don't import the dependencies completely, there will be an error. There's no even doubt about it. There will be an error because it will not be able to get the library that is supposed to do what it's supposed to do, because you didn't put the dependencies there. So it doesn't know what to do with that line of code or that function or that method, because you didn't put the dependencies. You didn't clearly define it at the top of the code, because that's the first thing it will read. Then interface definition, specify clear communication protocols between modules. This now, most of the time, in bad coding practice, a lot of people will have dependencies that they are not using. So you must make sure that all your dependencies are being used, and there's clear, you can specify where they are being used, because the more activities you write, the slower your application will be. So you must make sure that all your operations, everything you are doing is well written, and they are very, very specific. Because if they are not specific, it will make it very slow, and sometimes the behavior is unpredictable. These things are things that even the best coders still face. It's not something that once you know, that's the end. No. Even though you know it, you can write all the code and there will still be some behavioral flaws. Then you now have to adjust to it. Okay, so thank you very much. So that will be the end for today. I hope everyone enjoyed the class, and I would like to take questions.
Hello, sir. Good afternoon, sir. Hello.
Yeah, hello, I can hear you.
Thank you so much, sir. The session was really fast, and I personally learned a lot. I have a question. I actually dropped it on the chat board. Probably you are easy to take me. While you are explaining something like external customer and end users, I want to find out, is there any difference between the two? Are there difference between external customer and end user? Or are there instances where an end user can end up also being external user as well? Thank you.
Okay. For external users, these are people or organizations outside the company that actually use these things. They are almost the same, but they okay. Let me use the POS as an example. The POS guys, that's the people you go and collect money from. They are the external users. While the end users is you that go and collect money from them. Do you understand? The external customers are the ones that are with that POS box. You know they are not the owner. They are still under a company, maybe Money Point, OPay, and all that. But end user is you that go and collect. You take your card to them and you tell them, please, I want to withdraw from you. Yeah, so that's a typical example of external customer and end user.
Thank you, sir.
Okay, any other question, please? So should I go on with the practical?
We'll be having the practical next week. The time is fast spent now. We should have ended the class like 12 minutes ago. And a lot of people already left the call. So we'll be continuing this session. We'll be continuing this session by next week, same time. Yes, so please everyone, let's appreciate the trainer. Thank you so much, Mr. Tobi. Thank you so much. It's been really wonderful.
So much,
I'm sure everyone will be
really
looking forward to seeing you again. Thank you so much,
I
sir.
actually
Please,
apologize for taking so much time, but some things just have to be
no,
explained.
Yes, that's fine. That's fine. Thank you so much. We'll be hoping to see you again next week. So please, everyone, please make sure to fill in the attendance and the feedback form in the chat box. Please fill the attendance and the feedback form. Thank you so much, everybody, and have a great weekend. Thank you, Mr. Tobi, once again.
Thank you. Thank you.